Hello students, welcome to the class. So today is our day 24 of this JEE 40 days crash course, and we will start with a new chapter which is D and F block. Now in this class we will see mainly three things. First of all, we will look upon the general trends of D and F block elements and see what is transition elements. Then after, we will move on to some important compounds of your D block elements. Lastly, we will look upon the F block elements, which is our inner transition element. So this is our disclaimer. And if I talk about the analysis, then approximately 3.7% is the weightage of this chapter, and at least one question is included in each of the papers of your JEE mains. Now from 2017 to 2024, 9 questions were asked. What are the important topics from where questions are asked? So you will see mainly it from magnetic moment, okay, which is one of the general characteristics of your D and F block elements. So you will be asked for D block elements, okay. For S block elements, it is not in your syllabus. Then secondly, we will focus on the important compounds of your D and F block element, which include potassium permanganate and potassium dichromate. And thirdly is the lanthanoid and actinoid. In most of the cases, you will see questions from the electronic configuration of lanthanoid and actinoid, and also the reactions of the lanthanoids and actinoids. Okay, you can see here in 2024, question is from the lanthanoid and actinoids. Here it is from electronic configuration of that same. Then we have from magnetic moment and properties of K2Cr2O7. Similarly, in 2023, you would see a question from lanthanoids, and in 2022, the properties of KMnO4, and again the characteristics of actinoids and lanthanoids. Next, in 2021, questions were only from the lanthanoid and actinoid part. So you can clearly see that this part is very, very important. Lastly, in 2019, previously you can see questions from catalytic properties as well. Again, there was question from magnetic properties also. Now, I would suggest you that we would focus on the theory part, because similar to the D and F block, P block, we will see questions directly from the theory part. Okay, so we will invest most of our time in learning this theory part, and you should try to learn up all of these things. Now most of these things in your D and F block part are kind of logical in comparison to S and P block, where the things were much more ad hoc. So starting from the topics that we are going to cover today, as I said, first we will see what are transition metal elements. Next, we will see the general trends in the properties of this transition metal elements. After that, we will look upon the important compounds of transition elements, which are potassium dichromate and potassium permanganate. Got it? So this is the part related to D block. Coming on to the F block, we will look upon the properties, the electronic configuration. Now properties include both the chemical and the physical properties. So physical properties like your atomic radii, the boiling point and the melting point, and chemical properties means reactions with halogen, oxygen, or your hydrogen. Got it? Hi Archana. Hello. So starting with the first topic, which is transition metal. So to introduce you with this transition metal, first we have to know that what are D block elements. We know that from our previous discussion, group 1 and group 2 belongs to the S block, whereas group 13 to group 18 belongs to the P block. In the middle part, we have this D block elements, which starts from 3 and goes on to the 12. And in this particularly, D orbitals are filled progressively. So that is the most common point I would suggest. And then it is filled in 4 long periods. Okay, so we name it at first transition series, second transition series, third transition series. Moving on to the next, we have some information about F block elements. So the F block element are the one which are in your 4f and 5f orbitals. So I would say that it belongs to the 4th and 5th period, because here the highest quantum number possible is your 4 and 5. Now in these two part, your 4 and 5f orbitals are filled progressively, and these are together known as inner transition elements. Now a very important point regarding their group number. So every inner transition element belongs to the third group. Either you talk about 4f or you talk about 5f, they all belong to the third group of the periodic table. Next, talking about transition elements. So as the name suggests, it forms a bridge or a transition between the S block and the P block. So it is falling between the S and P block, so we name it as transition element. Now what is the property of transition element? It should have incomplete filled d orbital either in the ground state or in its all possible oxidation states. Okay, so let me clarify this with the help of some example. Suppose there is an atom which has completely filled d orbital in the zero oxidation state, but if you took it to the +2 oxidation state, then we are seeing a incomplete filled d orbital. Then in that case we will call it as transition element. But if you take the case of your zinc, where the zinc can show only one oxidation state, which is +2, in that case you will observe that zinc has a completely filled d orbital in the oxidation state also. Therefore we will not name it as the transition element. Got it? So you would only look for those oxidation states which are possible, or you would look for the ground state and judge that whether any of them is having a incomplete d orbital or not. If it is having an incomplete d orbital, then it would go to the transition element group, or if it is not having so, then it will not go to the transition element group. Now talking about the series, as I said earlier, there are 3 series of this transition metal. Starting from the 3D series, which goes on from scandium to zinc. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and lastly zinc. Next, we have yttrium to cadmium, which is our 4D series. And lastly, we have the 5D series, which goes from lanthanium to mercury. Okay, remember that you won't put this cerium and lutetium in the same part. Okay. Okay, one more important part. The 4f means the inner transition element in which 4f are filled, that belongs to the 5th period, not the 4th one. Sorry for that mistake. Similarly, the 5f orbitals, the inner transition element in which 5f orbital is filled, that belongs to the 6th period. Okay. So coming back to this point, so you have this cerium to lutetium in between of this 5D series, and it does not belongs to the D block, it belongs to the F block. Got it? Now, what about the important series in this? So the most important series where questions are mostly asked is your scandium to zinc series. You will see mostly from questions from here. Okay? And there is a very less chance of getting questions from this lanthanium series. So I would suggest you that you would focus on the properties and reactions of this scandium to zinc series, which is your 3D series. Next important thing is the electronic configuration. So transition metal have a general electronic configuration of n-1 d1 to 10, ns 0 to 2. Now this 0 that you are seeing is possible only in one element, and it is showing an anomaly in its electronic configuration. So to list that, I would just name you the exceptions in the electronic configuration that is shown by the D block element. Okay. Now, if I consider those D block elements which are not your transition element, why? Because they have completely filled d orbital both in their oxidized state as well as in the neutral state. So that includes your zinc, cadmium, and mercury, and its general electronic configuration is n-1 d10 ns2. Now, why I am saying it does not belong to transition element? If you take the neutral state, which is given here, obviously it has a completely filled d orbital. The second possibility is taking the oxidized state. So the only oxidized state possible for zinc, cadmium, and mercury is +2. Now, if you remove 2 electrons, that would of course be removed from the last orbital, which is ns. Okay. So if you remove 2 electrons from this ns, again you will see a completely filled d orbital for the +2 oxidation state also. Therefore, these 3 elements have no place in the transition element. Okay. Now talking about the anomaly in the electronic configuration, in that first stands our chromium, whose electronic configuration is 4s2 3d4. This is the expected one, means according to the Aufbau principle, this should be the electronic configuration. But due to dominance of stability of the partially filled d orbital, it has a configuration of 4s1 3d5, means one electron is going from 4s to 3d, creating a different kind of electronic configuration from the expected one. Similarly, if you look upon copper, it should have 4s2 3d9, but it is actually 4s1 3d10. Again, it is again happening due to the possibility of completely filled d orbital. Then moving on to the next, we have 5s2 4d4, which is seen as 5s1 4d5 for the molybdenum. Lastly, we have some great anomaly which cannot be explained with the help of half-filled or full-filled case. But I would suggest you that you should learn it. Here, the reasons are quite abstract and very difficult to conclude here. Therefore, I will just name those anomalies. So first include the ruthenium, which has a general electronic configuration of 5s1 4d7, not general, specific electronic configuration of 5s1 4d7. Here, we cannot see a case of half-filled orbital for the d. Remember, half-filled s orbital has no effect on the stability. Stability only comes from half-filled p orbital or d orbital or f orbital. Single orbital means the subshell which contains single orbital like your s orbital has no effect on your stability if it is having a half-filled configuration or a full-filled configuration. Got it? So this is very, very important to remember. Now, this is an anomaly which cannot be explained on the basis of half-filled and full-filled, but you have to remember it. Now, similarly, as I said earlier, that one of the element has 0 electrons in the s subshell, and that element is palladium. You can look upon the electronic configuration which is found experimentally. It is 5s0 4d10. Now, this is the only element in your d block element, which d block series, which shows a 0 electron count in the 5s orbital. So this is a very important anomaly in the electronic configurations, and questions are asked from this point. Okay, so remember, this is very, very important. The expected one would be 5s2 4d8. Got it? So this palladium is coming from the 5d series. Got it? So we have 3 series, remember, 3d, 4d and 5d, and this is something which is important from the 5d series. Next, moving on to the second general property, which is atomic and ionic radii. So if you look upon this graph, what you can see is there is a constant decrease on moving from left to right up to a point in the d block elements. But after a point, you would see that the atomic radii is not changing in a significant manner. And why it is happening? It is happening due to the poor shielding effect of the d electrons. Okay, means the expected contraction in the atomic radii is not seen due to the involvement of d orbital in the middle. Got it? Is it clear? So this is very, very important, right? Next, if I talk about the filling of 4f and 5d orbital, then this 4f orbital filling results in the subsequent decrease in the radii of your given series, and this phenomena is known as lanthanoid contraction. Means the contraction which is seen abruptly from this point to this point. So you can see that the atomic radii is dropping at a very drastic situation. And what is the reason behind it? The reason is the involvement of the 4f orbital. Okay, so after lanthanium we have the involvement of 4f orbital, and as a result of that, since your f orbital is the most diffused one, so as you move from a lower value of L to a higher value of L, means from S to P to D to F, the shielding effect of the orbital decreases because that same amount of charge is diffused over a large area. As a result of that, the shield become less efficient from the f orbital, and hence the electrons are pulled more strongly by the nucleus. Therefore, the electrons comes together, and the subsequent decrease in size is very much significant in this case. Got it? So this drastic change is not seen in the case of upper periods, right? Like in the case of 3D. You can see it very clearly here. So this is the one which is representing 3D. Okay. Now, between the 3D and 4D, there is a large gap of atomic radii. But as soon as you move to the 4D and 5D, you compare 4D and 5D. So this blue line is for the 4D and this red line is for the 5D. So the corresponding element has a very less difference in their atomic radii. You can clearly see the gap. This gap is very much less as compared to the gap between the green and the blue line of this figure 4.3. So this is a direct outcome of the lanthanoid contraction. Is it clear to you? So this is very, very important. What did I say? So in the 3D and in your 4D, there is no lanthanoid contraction. So the size is almost very much having a difference here. You can see there is a large difference between the two sizes. But upon the addition of the next shell, which is the fifth shell, the rise in the atomic radii is not that much significant, and that is due to the involvement of the f orbital in between. That makes your size of your 5D series element almost closer to the 4D series element because of the poor shielding effect of the f orbital, and this is known as lanthanoid contraction. Now, the atomic and ionic radii have a same kind of trend for the D and F block elements. Moving on to the next general property, which is enthalpy of atomization. It is basically the energy required to pull out an atom from a given lattice, and this transition element, they exhibit a very high enthalpy of atomization. What is the reason behind it? So you know that most of the element of the D block elements are metal. I would say all of the elements are having a metallic nature. Now the second thing you know is that metals have free electrons which moves in your lattice, and that is responsible for creating conduction, your electrical conduction as well as heat conduction. Now these free electrons acts as a bridge between two atoms and bind them strongly together. Okay, what did I say? So the free electrons of the metals in the case of transition element, they kind of overlap with each other between the two atoms, and they create a very strong interaction between the two atoms, and hence they are very difficult to separate from each other. Now this free electron phenomena is kind of very much influential in your boiling point and melting point as well. Got it? And what is the reason behind it? The reason is the large number of free electrons or the unpaired electrons in the atoms. So this is the graph representing the melting point as well as the enthalpy of atomization. So the transition element shows a high melting and boiling point, again due to the involvement of electrons which are free, and they create a interatomic bonding. Now this is the thing which we know, which we popularly known as the metallic bonding. So why are the metals why metals are so strong and so rigid? The reason is very clear, because they have a large number of free electrons which are unpaired. Now the electron from one atom and the electron from the other atom, they overlap with each other and make a very strong metallic bond, and the lattice becomes very rigid and very robust. As a result of this, three properties are being influenced. First is, it is very difficult to pull out an atom, therefore the enthalpy of atomization is very much high. Second, it is very difficult to melt them or boil them, so they have a high melting and boiling point. Now if you look upon the series, you would see that after a certain time there is a dip in between, right? So there is a clear dip, means it is first it is increasing, suddenly there is a drop in between. What is the reason behind it? The reason is that once the orbital is half filled, so suppose it comes to D5, then what will happen? It will result in pairing of the electrons. Okay, so as soon as the half filled is reached, then in that case electrons are very difficult to roam. So initially you know that the unpaired electrons are free to roam, but you know that the stability of half filled orbital is very high. So to release those electrons becomes very difficult. As a result of that, those elements which have a half-filled d orbital, they show low enthalpy of atomization because their electrons cannot be involved in the metallic bonding. But slowly, as soon as you keep on adding electron, this number gets on increasing. Okay, you can see that there is an increase. But after some time, it again starts to decrease. Why? Because we see a D10 configuration where all the electrons become paired to each other. Got it? Is it clear to you? Suppose I am taking the D4 configuration. Means there are 4 electrons available for metallic bonding. Then I move from D4 to D5. What will happen? Now there are 5 electrons available for the metallic bonding, but these 5 electrons are present in the half-filled configuration. So it is very difficult for them to release. Got it? Now what we do? We move on to the next element of that same period. It becomes D6. So one of the electron is being paired up and rest of the 4 electrons are free to roam. And this is not the case of half-filled or full-filled. Got it? So these 4 electrons help in metallic bonding. So there is an increase from this to this. But again, if you keep on pairing the electrons, the number of unpaired electrons decreases and hence we see a decrease in the melting point. So this is the overall reason I would say. So initially D1, D2, D3, D4, then a dip due to D5 and then a sort of increase. But again, due to pairing, we see a decrease. And this is the reason we are seeing this kind of graph both for metallic bonding, both for melting and boiling point as well as the enthalpy of atomization. Okay, I hope this is clear to you. Now you would notice one more interesting thing. And what is that? If you look upon the melting point, then it is highest for the 5D series. Okay, this is the green line, it is present at the top. But you look upon the enthalpy of atomization, then it is lowest for the green one. We are seeing an opposite case here. So I am leaving this rationalization up to you, that how do you rationalize this point. What did I say? That the melting point of the elements of your 3D series is very much low, but the enthalpy of atomization of that same 3D series is very much high. Okay, now this is very important to think about and a very important point also at the same part. I hope you got my point regarding this graph, and this graph is also very important. You would see questions from it, and there would be statemental type questions regarding the melting point, boiling point, and your enthalpy of atomization, hopefully. Next, moving on to ionization enthalpy. So, here is a table for the ionization enthalpy of the 3D series. I said it earlier that we will mainly focus upon 3D series. So, starting from scandium, titanium, vanadium, you would see an increase here. Okay, there is an increase. Then there is a sort of decrease starting from titanium, then vanadium, chromium. Again, it increases up to manganese. Right? There is not a continuous increase, but that increase is disrupted in some part, and that is clearly to the involvement of d orbital. As soon as we are talking about your S and P block, we are in the heaven. But as soon as we are introduced with this d block elements brings up the d orbital, and that creates a lot of difference between the trends, and you can clearly see it here. But we will look upon a overall case. So what is happening? First of all, it is increasing up to manganese, and then this thing is completely decreasing. You can see here that after this point, it is decreasing slowly and slowly. 17, 62, then 58, 36, 45. What is the reason behind it? Again, that same half-filled d orbital. Now for this, I would suggest you that you look upon the electronic configuration. So this is the enthalpy, ionization enthalpy for the removal of first electron, which is written as delta 1H. Then this is for the removal of second electron, and this is for the removal of third electron. Okay, and you can clearly see that the energy is increasing as you are moving from 1 electron to 2 electron to 3 electron, whose reason is very obvious, because now we are removing an electron from a already positively charged species. Got it? And the reason behind this graph or this values is your electronic configuration. Got it? Then next is oxidation state. Now this is something which is very, very important. After your melting point, boiling point and atomization, this is the next important thing. So your d block elements are capable of showing a very variable oxidation state due to the poor d electrons electrostatic force. Means the electrons of the d orbitals are hold very lightly as compared to s and p. So electron removal is easier on any extent, and therefore we see a varied oxidation state possible for this transition metal. So as I said earlier, that your n-1 d electrons and ns electrons have a very low energy difference. Therefore they are capable of showing a variable oxidation state. So we can remove electrons from s as well as from d also. Now here is a list of possible oxidation state for 3D series, which is the most important one. First of all, for scandium, the only possible oxidation state is +3. As we move to the middle part, you would see that the number of possible oxidation state increases. For manganese, it becomes +2, +3, +4, +5, +6 and +7, meaning that there are total of 6 oxidation state which are possible for manganese. And what is the reason behind it? The reason is your involvement of d orbital. Next, if you move on to the right, what will happen? There again is a decrease in the number of possible oxidation state. Okay, so can you rationalize it? Why it is happening? Why we are seeing an increase in the oxidation state and then following a decrease in the oxidation state? Can anyone tell me what is the reason behind it? You can just post it in the comment section. Anyone, can you tell me what is the reason behind this trend? Why it is first increasing and then it is decreasing? So think about the free electrons that are available for removal. It is quite similar to your boiling point and melting point. Okay, so hopefully you may be getting a picture that what is the reason behind it. Just think about it more and write it here in the comment section. Anyone? So let me make it clear for you. Initially, what will happen, as the number of electrons are increasing in the orbitals of your d, okay, then the number of which are electrons which are possible to remove are also increasing, because the electrons present in the d orbital are very susceptible to removal. But after a certain time, which is your manganese, what happens is that your electron count increases to a very large amount, and that increases the effective nuclear charge on it. You know that size is decreasing as we're moving from left on to right. So due to this size decrease, your electrons are now very much closer to the nucleus, and hence they become difficult to remove. Yes, you are absolutely right. So initially we have fewer electrons, so we have fewer oxidation state, but it should be increasing constantly up to the last. But due to the decrease in size, after a certain interval of time, the effective nuclear charge on the last electron increases goes on increasing, and hence after manganese we see that the number of possible oxidation state decreases. Got it? So this is the reason for the oxidation state of your different element which are showing a anomaly trend. Moving on to the next, which is standard electrode potential. We have learnt about this electrode potential, which is basically the potential required to remove the electron in the standard condition of standard temperature and standard concentration. So considering about this, first we will talk about how do we decide the solubility of a given ion in the water. So that thing also comes from the standard electrode potential. So when you are trying to dissolve something in water, so what are the two steps? First, you should ionize it, and second, you should try to hydrate it in water or dissolve it in water. To remove the electron, we are up to give energy to it, and to dissolve it into the water, the energy is released. Now, the amount of energy which is released is a supporting factor for this. More energy is released during the hydration means the solvation is much more easier and the conversion of Cu to Cu2 plus is very much easier. Got it? So when you will go to a place, when that place is pleasant for you, right? So that same thing is applicable to your copper atom. So your copper atom will go to a copper 2 plus when the copper 2 plus state is pleasant for that given species. And when it is pleasant, when it can be stabilized by the interaction with water, which is your hydration energy. So greater is the amount of energy released during the hydration apart from the energy which is involved in the removal of electron. Easier will be is conversion from copper solid to copper 2 plus aqueous. Got it? So in this way, your standard electrode potential is very much important. Next, if you are moving along a period, we know that from moving left to right, the metallic character decreases. As a result of that, the electropositive character also decreases. So there are anomalies in it. Suppose if I talk about manganese, nickel and zinc. So your manganese 2 plus has a completely filled d orbital. Therefore, its solvation or its conversion is very much easier. Okay, so they are showing a very negative E naught value. Why? Because they are going to a stable oxidation state. Similarly, you can tell about zinc, which goes to a D10 configuration, and for nickel the thing is different. It is about the hydration energy. So basically, why Mn goes to Mn2 plus? It is due to the stability of half filled orbital, which is D5. Then for zinc 2 plus, the zinc goes from D10 S2 to D10, which is a completely filled d orbital case. What about nickel? Why is nickel having a negative value? Because of its high hydration energy in the water. So nickel 2 plus has a very small size. As a result of this, it has a high charge density and a greater capability to hold the water molecules around it. Therefore, it releases a large amount of energy and hence it has a negative hydration enthalpy or a negative E naught value. Got it? Moving on to the next, what about scandium 3 plus and iron 3 plus? So they are very much stable due to the noble gas configuration and D5 respectively. So for scandium 3 plus, it goes to the noble gas configuration because it is the third element of that period. If you remove 3 electrons, it will result in a electronic configuration which is equivalent to the noble gas configuration. And for Fe3 plus, if you remove 3 electrons, it will have a D5 configuration and hence it has a higher tendency to go into this oxidation state specifically. Our next trend is your stability of your higher oxidation state. So it is generally seen that higher oxidation states are stabilized by electronegative elements, which are highly electronegative in nature. So for example, if I consider about titanium, vanadium or chromium, these three elements are here showing an oxidation state of +4, +5 and +6. And it is only possible to attain this oxidation state when they are in a combined state with the halides. Why halides? Because halides are highly electronegative in nature. So this is the idea basically. So if you want to say neutralize an ionic species, what you will need? You will need something which is kind of highly electronegative or highly negatively charge containing thing. Okay. So titanium in its higher oxidation state will have a greater positive charge. To stabilize that, we should have something which has a greater electron character, and that is your halide. Got it? So always remember this, your higher oxidation states are stabilized by electronegative element, and that is the reason hydrides of your higher elements or heavier elements are not that much stable, because hydrogen is very less electronegative in nature. What about manganese? So the +7 oxidation state of manganese is not represented in simple halides. For that we need a combination of two, which is oxygen and fluorine. So to show a +7 oxidation state for manganese, we need to have 3 oxygens and 1 fluorine, and that combined together results in the stable +7 oxidation state. Okay, so you won't see a MnF7. Okay, so this is something which is not possible. Instead of that, we have MnO3F. What about trihalides? So trihalides are possible only for iron and the cobalt, and again For that we need some highly electronegative element, which is the highest electronegative element in the given periodic table, fluorine. Okay, so we have FeX3 and COF3. Next, what about the increasing order of oxidizing power of the series? So it's very simple. So first we have VO2 plus, which is having an oxidation number of vanadium as +5. Then we have dichromate ion, and lastly we have permanganate ion, where the oxidation state is +7. So it's very obvious, the one which has the highest oxidation state is capable of oxidizing other species in a quite good manner, because they can easily accept electron from the other element due to its high positive charge on the metal ions. Next, so the low oxidation state is not stabilized by fluorine. So that is very obvious. The opposite is also true. So if you take the case of suppose 2Cu2 plus 4I2, then it forms Cu2 plus Cu2I2. Got it? So we are implying iodine here, not your fluorine, because fluorine is very electronegative and it can only stabilize copper in its high oxidation state and not in its lower oxidation state. For that case, we need some lower electronegative halide such as iodine. Remember, your CuIT is not, CuI2 is although seen in some cases, but it is not stable. It quickly decomposes to form Cu2I2, and that is the case which is happening here. Next, if I talk about the Cu plus, so most of the compound of Cu plus is not stable. As soon as you introduce your Cu plus in water, it is oxidized to Cu2 plus and copper. Means it is showing a disproportionation reaction here. Okay. So anyone who has a doubt in this part? So we have discussed a lot about the trends. So if you have a doubt, you can just clearly ask it here, or else we can move further. Okay, so next we can just list all the possible higher oxidation state which are stabilized by oxygens and fluorine. So talking about fluorine, we are clearly seeing that the +7 oxidation state is stabilized by the CrF6. Okay. Similarly, if I talk about the +7 oxidation state, then that can also be stabilized by oxygen alone. So that for that we have an example of Mn2O7, where manganese is having an oxidation state of +7. But if I try to make a compound with the fluorine, where the manganese is having a +7 oxidation state, that would not be possible. So we have seen an example. What would be the possible case? It should have a mix of oxygen and fluorine, which is MO3F. Here you can clearly see that the higher oxidation states are clearly stabilized by the higher electronegative elements such as fluorine and oxygen. Is it clear to you? So here X in the first table, if you see, then the X1 is representing fluorine, X2 is representing fluorine to bromine. So X1 is representing fluorine to bromine, X2 is representing that it can have fluorine chlorine both, and X3 is representing that it can have chlorine to iodine, means chlorine, bromine and iodine, all three. Okay, did you get my point? So X1 represents fluorine, chlorine and bromine, X represents fluorine, chlorine, bromine, iodine, all are stabilized. X2 represents fluorine and chlorine only, and X3 represents chlorine, bromine and iodine. Suppose if I look upon TiX2, then it has a superscript of 3 numeral. Okay, that represents that your titanium is stable in this oxidation state, which is of +2 with chlorine, bromine and iodine, because X3 stands for chlorine, bromine and iodine. So I would suggest that you should remember this table. This is very important, this one and your oxidation state table. If you want to score this in your D and F block element, since it is a very small chapter and a very good one also, you can easily score marks in it. Therefore, I would suggest you to remember the tables, especially your oxidation state and your higher oxidation state. I am not telling you to remember the values of ionization enthalpy. This is not viable at all. But you should learn the possible oxidation state, first of all that, and second is this higher oxidation state stabilization by the fluorine and oxygen. Next, moving on to the magnetic property. So your D block elements are capable of showing paramagnetism. Some of them have unpaired D electrons. Now, These d electrons, unpaired d electrons, shows paramagnetic nature due to the susceptibility which is possible for the unpaired electron. So as soon as you introduce into a magnetic field, what will happen? It will align its domain according to the magnetic field that you have applied. Now the amount of your or the extent of your magnetization depends upon the number of unpaired d electrons which is present in the given element. So its formula is, if you just quantify it properly, so the magnetic moment can be calculated as mu is equals to n into n plus 2 root under Bohr magnetron. So Bohr magnetron again is at a unit to represent the magnetic moment. Here n represents the number of unpaired electron in an ion or in a neutral species. Next is your alloy formation. So alloys are what? They are the homogeneous mixtures of two solids or two metals, and they are specifically designed for specific purpose. For example, there is a alloy which is used in your heater. Okay, so we need two things. First thing should be of higher conductance, and second thing should be of high robust nature, because in heaters the temperature which is reached by the coil is very much high. So we take two materials such as copper or something like that and mix it with a robust metal, okay, to create a combination which is capable of standing high temperature as well as conducting electricity efficiently. Sorry. Next, why transition metals are capable of showing this alloy nature? The reason is that if you look upon the graph of atomic size, then their atomic radii is not varying in a drastic way as compared to S and P block trend. So if you want to replace a ball or an element with another element, you would need that both of the element have comparable size. Okay. Suppose, for example, if your math teacher is absent, then what you would try? You would try that you send a math teacher as a substitution for that same. Got it? So that same logic is applied here. If you are removing a atom of radii 214 picometer, then you would try to replace it with an atom which is having a radii near to that 214 value. So that is the reason your transition metals are capable of forming alloys, because their size is varying in a very smooth way, especially in the middle part of your transition series. Got it? In the start part you can clearly see an abrupt decrease, but in the middle part the things are not that much drastic for a given particular period. Next, can we see an example? Yes. So brass, which is a very famous alloy made up of copper and zinc, and bronze, which is a famous alloy of copper and tin. So these are some alloys which are very much useful in our day-to-day life. Our next general trend is regarding the formation of colored iron. So your D and F block element both are capable of showing a very much vibrant color. Okay. So what is the reason behind that? The non-degenerate orbitals of D in the presence of ligand. So they show various characteristics due to which they are showing color. So basically what happens when your d block elements are forming complex, then their d orbital is splitted into two halves. Okay, you will learn about that in the coordination compound. We have two sets, T2G and EG. In that case, what happens? Some of the electrons from the T2G are excited to the EG, or from EG to the T2G, depending upon the tetrahedral of the tetrahedral compound that we are considering. As a result of this transition, after some time the electrons jumps back to the ground state, releasing some amount of electromagnetic radiation, which results in the color formation by the ion. Okay, so what is the reason behind it? It is basically DD transition. What happens? Your d orbital is splitted into two energy levels, and electrons are excited from one energy level to the other, and they are depleted back to the previous one, releasing electromagnetic radiation. Now there are orbitals with different energies, but the d orbital are resulting in a set of orbital which are having a very low difference in their energy level, and due to which the transition is possible. Okay, so you won't see a transition from 2s upon 3d. because their energy gap is very much high. But since the splitting is taking for the d orbital itself, the d orbital itself is splitting into two sets. So as a result of that, the energy difference between the two sets is very less, and hence this dd transition is possible. So this is the reason they show various colors. Now next, what color it will show? It will depend upon the color which was absorbed. So you know that first electron will go on to the higher state. So it will absorb a certain electromagnetic radiation of a certain frequency and certain wavelength. Then upon de-excitation, it will release some energy, and that is known as complementary color of the light which was absorbed. Okay. So that is tracked with the help of the Govt wheel. We will see it in the upcoming slides of your coordination compound in the next class. But you should remember this point, that your dd transition results in the excitation of electron and your revolve back to the initial ground state. And during that, whatever color is absorbed, complementary color is released and complementary color is observed by the observer for that particular ion. Next, what about those elements or those compounds which have 0 electrons in the d orbital? What will happen to them? How will they show color? So there is a different phenomena for those kind of compound. For example, in V2O5, where vanadium is showing a +5 oxidation state, in spite of having this d0 configuration. So if you remove 5 electrons, you will be left with 0 electrons in the d orbital. Still, it will show colored compound, and the reason is LMCT, which is known as ligand to metal charge transfer. Now, this is a new term. We will discuss about this in detail in your next upcoming classes of coordination compound. But in short, if I discuss, then this O5 that you are seeing, these are your ligands. And this V that you are seeing, this is your central atom. Okay. So what will happen? Due to the high positive charge of your vanadium, the negative charge from oxygen is transferred onto the metal ion. And as a result of this charge transfer from the ligand onto the metal, we see a color change or a coloration of the V2O5 compound. Okay. So the first reason is your DD transition in most of the cases. And the second reason is your LMCT. Got it? Which is ligand to metal charge transfer. So this thing is known as charge transfer spectra. So there are two kind of charge transfer spectra. One which is shown by this V2O5, where the metal is present in higher oxidation states such as +5, and second is shown by the metals which are present in lower oxidation state like +1, +2 or 0. So that would be known as metal to ligand charge transfer. In that case, the electrons are transferred from the metal onto the ligand. That opposite thing is seen. So questions are now not asked from that point directly, but still you should know it. Okay. Then you will be able to predict that which of the given compound will show coloration and what is the reason behind it. Okay. So we'll discuss this in detail in your coordination compound. After that, your next point is complex compound. So your transition element are capable of showing the formation of complex compound, and it is due to the reason that they have a very small size and a high nuclear charge. Means in comparison to the charge they bear, the size is very small. As a result of this, they show a high charge density, and hence they are capable of accepting lone pairs from the ligand. So here ligand is corresponding to the surrounding atoms, which is surrounding your central metal ion. Okay, suppose in the case of V2O5 we have oxygen atoms. Next, the electrons from this ligand are donated into the vacant d orbital of the metal ion, and as a result of this interaction, where your ligand is donating your electron to the metal ion, it forms an interaction, right? As a result of this interaction, we see the formation of complex compound, a large number of complex compound which has a very high utility in the industrial process. Okay, so nowadays your complex compound is a very specific and a very popular topic in the area of research and development. Next is your catalytic property. So to understand this catalytic property, first you should understand that what is catalyst. So catalyst is something which shows the increase in a rate of reaction. Now how does it show an increase in the rate of reaction? So the basic thing your catalyst does is the exchange of electron. Okay, so it is not involved in the reaction, it enhances the rate of reaction. How it does so? Basically, it facilitates the transfer of electron. If you see in a reaction, only one thing is occurring at a fundamental level, and that is exchange of electrons. So your catalyst, what it does, it facilitates this change of electron through a pathway which is having a lower energy requirement. Okay, now what two things it does? It accepts electron and it releases electron. Now to fulfill this pathway or to fulfill this role, it should have two properties. It should have that oxidation state in which it can accept electron, and it should have that oxidation state in which it should release electron. Means it should have variable oxidation state. It could exist in variable oxidation state, and that is something which is very prominent for your D block elements. You have seen it in the common oxidation state which are possible for D block element. As a result of this, since they can show multiple oxidation state, so they can act as a very good catalyst. And nowadays your most of the organic reactions which took a very long time to complete are completed in just a fraction of time due to this transition metal involvement. Okay, so it is increasing the efficiency of your organic reactions by a large amount. Next thing is the providing of the large surface area. So you would say that surface area could be provided by any other element. Why the D block element? Because your D block element are at the same time very unreactive. So talk about copper, you talk about silver, you talk about your gold. So they are very less reactive. So they do not participate in a reaction, but they provide a surface area. So two things are there due to which they are showing a very high catalytic property, which is first is multiple oxidation state, which facilitates the exchange of electron and hence making them a good catalyst. Second is providing a good surface area. Now you would say that many elements are there which can provide this surface area. Why your transition element? So two things are there. First, they are less reactive. Second thing is that their sizes are very small. Okay, so in between two metals, your non-metal can be inserted like in a cavity, and there your reaction can take in participating close proximity. Suppose you are doing a reaction in a large vessel where you are dropping 2 drops on one reactant and 2 drops of the other reactant. Then there is a very less probability, then they can collide together and do a reaction. Now you make the size smaller, means the proximity is made close. In that case, the reaction will take place faster. Here also that same role is played by the condition metal. They provide a cavity which is a very small area where the reactant and product can come very close to each other and do a reaction itself. Got it? Moving on to the next trend, which is formation of interstitial compound. So as a result of this cavity, it is utilized in the making of interstitial compound. Small non-metals like hydrogen, carbon and nitrogen, they are inserted into this crystalline solids of transition metal into their cavity, forming interstitial compound. Now as a result of this, many things are enhanced in the physical and chemical characteristics of this compound. First, they would have a high melting point because now we have a very high density due to the insertion of your non-metals into the cavity. Got it? Means the parent metal will have a low melting point as compared to its daughter interstitial compound. Next, they will be very hard, obviously due to its density. And third thing, they will have same metallic conductivity. That means metallic conductivity is retained. It is not changed in any aspect. So these are some important properties of your interstitial compound. Now moving on to the next topic, which is some important compound of transition element. So we will learn about two. First is potassium dichromate and second is potassium permanganate. So about K2Cr2O7, if I say, so this is basically obtained from the ore known as ferrochrome or chromite, whose formula is FeO.Cr2O3 or FeCr2O4. How it is obtained? So these are some preparation methods. First of all, your FeO.Cr2O3 or FeCr2O4 is reacted with a sodium carbonate in the presence of oxygen, and that results in Na2CrO4, Fe2O3, 8CO2. Next, this Na2CrO4 that you have gotten upon the removal of your iron with sodium, you acidify it with the H plus, and that will result in a sodium dichromate. Okay. Next, what will you do? You will again react it with the KCl, and that will result in K2Cr2O7. So first thing that we are doing is the removal of the iron with sodium. Then you are oxidizing your chromium to a higher oxidation state with the help of H plus, and then you are bringing back the counter ion, which is potassium, with the help of KCl, and hence you are getting your required potassium dichromate. Now these three equations are very, very important for you. Okay. If you would see a direct question, you can easily attempt it. Next, why it is happening? Because your sodium dichromate is much more soluble than the potassium dichromate. Okay, as a result of this, you can see that it is precipitated. Next is your structure. So if I talk about the chromate ion, then it has a tetrahedral structure, but it is interconvertible upon the change of pH. So you can see here that as we are decreasing the pH by introducing H plus, your chromate ion is converted into Cr2O7 2-, and here two units are joined together with oxygen acting as a bridging atom. Okay, so all this is happening, this conversion of chromate ion to dichromate is occurring due to the insertion of H plus ion or due to the change in pH. So this is very, very important for you. Got it? So this conversion is dependent upon pH. Next, what about the chemical properties? So here are the reactions. It will mostly act as an oxidizing agent. So let us start with the first one. So if you are increasing the OH minus condition, then obviously if you are increasing the H plus, your CrO4 is going to Cr2O7. If you do the opposite thing, then it will again go to the CrO4, which is yellow in color. If I treat it with the FeSO4 dot and H2SO4, what will happen? What it will result in? I said you it acts as an oxidizing agent. So it will oxidize the iron to iron 3 plus. Next, if I treat it with the Ki, then the I minus is oxidized to the I2. You can clearly see that oxidation is taking place for each of them. Moving on to the next one, which is H2S. Here also the sulfide ion is converted to the sulfur, which is a lower oxidation state. After that, we have the SO2 and H2SO4. Okay, here the sulfur is in a lower oxidation state and it is moving on to a higher oxidation state upon reaction with potassium dichromate. Now again, this is a oxidation of sulfur, but to a different oxidation state as compared to the previous one. Our next is the most popular chromyl chloride test, in which we take the K2Cr2O7 and react it with the NaClH2SO4, and that results in the formation of chromyl chloride Cr2OCl2. After that, this thing can also be used for the oxidation purpose of organic compound as well. And here it is converting your alcohol to acetaldehyde directly, or if you are taking a secondary alcohol, then it is converted to ketone. So that depends upon the thing that you are taking. In place of that, if you take your acetaldehyde, then that thing is directly converted into acetic acid if you take this thing. Got it? Is it clear to you? So this is which is very, very important. So here we are directly taking aldehyde rather than the alcohol. So alcohol is converted to aldehyde, aldehyde is further converted to acetic acid, and in this case, since it is a secondary alcohol, so it is converted to ketone only. Moving on to the next compound, which is potassium permanganate. So I would suggest you to take a screenshot. Those reactions are very, very important for you. So talking about the potassium chromate, so it is obtained from pyrolusate, which is MnO2, and it is the ore of obtaining a KMnO4. How it is prepared? So the first step is the conversion of MnO2 to KMnO4, K2MnO4. So here also this conversion of MnO2 to MnO4 is dependent upon the pH. So if you are increasing the pH by increasing the OH minus, then you are converting into the manganate ion. After that, it is green in color. And next thing is the conversion of your MnO4 2 minus to MnO4 minus. How it is done? Again, the pH change is playing a role here. So if you introduce 4H plus here, then it will result in MnO4 minus. So we are changing pH 2 times to convert your MnO2 to MnO4 minus. Next, what you would do? You would just exchange the ion. Now, we have a commercial preparation also. Here what we do is we fuse the MnO2 directly with the KOH and oxidize it with the air or KNO3, and that directly results in the formation of the required manganate ion, which is green in color. Now the structures are again very, very important. So this is the second method that you can see here. MnO4 2- is treated with alkaline, your electrolytic condition in alkaline medium, and that also results in the required product. Okay. So first MnO2 is converted to MnO4 2- and then MnO4 2- is converted to MnO4-, which is purple in color. Here, if you look upon the two structures, then they are same. Both MnO4 2- and MnO4- have the same structure, which is tetrahedral. Is it clear? So here will be a negative sign in the tetrahedral magnet, therefore it will have a total of 2 negative charge, and here it is having a single negative charge. So this is missed here, sorry for that. But this one is green in color and this one is purple in color. Then we have the chemical properties of potassium chromate. So this thing also used in the oxidation part. First of all, if I treat it with the H2O2, then oxygen is oxidized to O2. Next, if I treat it with the oxalate ion, then it is again oxidizing your carbon. Further, it oxidizes the Fe2 plus to Fe3 plus and your SO3 2- to SO4 2-. Then after, it can self-oxidize itself from Mn2 plus to MnO2. Next, your halides are converted into their respective zero oxidation state, and lastly your sulfide is converted to sulfur. So here are some more reactions. So this all are done in the acidic condition. If you do it in the alkaline and neutral solution, then I- is converted to IO3-, H2S is converted to sulfur, S2O3 2- is converted to SO4 2- with release of MnO2 rather than Mn2 plus. Lastly, if you treat your Mn2 plus in place of ZnSO4, then it results in MnO2. Got it? Then this KMnO4 along with OH- is also known as the Bayer's reagent. If you treat this combination with C double bond C, then it loses its color. By what? By reducing this double bond. Okay. Next, in the presence of sunlight, it is converted into KMnO2 and O2, and it can be decomposed into K2MnO4 and MnO2 plus O2 in the presence of heat. Next, if you treat it with H2SO4, then it can result in two products. First one, if KMnO4 is in excess, then that would result in M2O7. Whereas if your acid is excess, suppose your H2SO4 is in excess, then in that case it would result in KMnO3. Now this is the second important table regarding your potassium permanganates. So first one was regarding your potassium dichromate, and this one is for potassium permanganate. And these two chemical properties table are enough for your preparation. Got it? Lastly, we will talk about the inner transition elements, which are your F block element. So they consist of two series, lanthanoids and actinoids. What about lanthanoids? So they start from cerium and end up to lutetium, and they're also known as the rare earth element, whereas your actinoids are known as the radioactive element and starts from thorium and ends up to lawrencium. Next, starting from first of all lanthanoids. So 14 elements are present in this row of this lanthanoid, and they are placed in the bottom of the table. Here, the 4f orbital are progressively filled. So listen to every point, it is very, very important for you. What about the general electronic configuration? So it is 4f 1 to 14, 5d can be 0 to 1, and 6s is always 2. Next, cerium, gadolinium and lutetium all have 5d orbital, have electrons in the 5d orbital as well, means they have 5d1 possibility. Except from these, all have 0 electrons here. Now you can easily fill in the 4f accordingly if you know the overall series. Okay, you keep electrons filling in the 4f. As soon as you come to cerium, put 1 electron in the 5d. Same for Zd and same for lutetium. Then you can get the configuration of each of them. So this is a trick to remember them. But for that, you should remember the lanthanoid series. Next, this is the configuration of cerium, and these three are important for examination also, because questions are asked from the electronic configuration of these three only, because these three have anomaly in them. So 4f1 5d1 6s2 for cerium. Then for gadolinium it is 4f7 5d1. So rather than keeping it as 4f8, it is 4f7 5d1 6s2. And lastly we have lutetium, which is 4f14 5d1 and 6s2. And the obvious reason for gadolinium and lutetium is the half filled and full filled orbital. For cerium it is still unknown. Next, what about the properties of lanthanoids? So, here are some important properties of the lanthanoid. First, their atomic and ionic sizes are decreasing from left to right. And why is it so? It is due to the nuclear charge increase. This is also known as the lanthanoid contraction. Now, what are the consequences of lanthanoid contraction? First of all, the basic character of your hydroxides decreases from lanthanium to lutetium because their size is decreasing. So, they are very much less capable of donating electrons as their electrons are very closer to the nucleus. So, this is very important. Next is the normal size in increase from scandium to yttrium to lanthanium disappears after the lanthanoid. Okay, so the size is decreasing abruptly. We have seen this in the D block elements such as zirconium and hafnium, niobium and yttrium, and molybdenum tungsten. They have nearly same size. So these are the comparison between two series. Okay, between the 4D and 5D. This is zirconium is 4D and this is a 5D hafnium. Similarly, NB is niobium is from 4D and YA is from 5D. And lastly, molybdenum is from 4D and tungsten is from 5D. So these couples show a very close atomic radii. Why? Because their size has decreased abruptly due to the lanthanoid contraction. Okay. Lastly, what about its appearance? So they show silvery white appearance and they are soft metal. Second, they are highly reactive. So they are easily tarnished in air. So basically they are reacting with the oxygen. Moving on to the next property. So talking about the chemical properties, it shows a +3 oxidation state, both in the solid and aqueous solution. Now this point that you are seeing is kind of minimalistic but very important. So you can form compounds with any of the halides or your hydrides or your oxides using this same oxidation state. Okay. Next is neither your Lu3 plus nor your lanthanium 3 plus shows any color. Lastly, your lanthanoid ion with XF electrons have similar color due to this with 14 minus X electrons. So it's very obvious because the number of unpaired electrons is same. Okay, now what about the lanthanoids which have F0 type? Suppose we take the example of lanthanium 3 plus and cerium 4 plus, and F14 type which are yttrium 2 plus and lutetium 3 plus. So they all are paramagnetic in nature. Now this is very important for you. Now what is the reason behind it? For any species to show paramagnetic nature, it should have unpaired electron. But here they are showing a paramagnetic nature instead of having a full-filled or zero-filled orbital. The reason is that they have something known as orbital contribution. We will not talk about this in detail. You can only remember the name that this have your paramagnetic properties, although having a zero electronic configuration in the F or fulfilled configuration in the F due to the orbital contribution. So their paramagnetic nature is not coming from the spin only momentum, means the spin of the electron, but it is coming from the orbital momentum. Next, your neodymium shows maximum paramagnetism. Okay, moving on further with the property of lanthanoid. As I said that the +3 oxidation state is shown commonly by the lanthanoid. +2 and +4 are also possible, but they are not that much popular. For example, cerium 4 plus is favored in some case because it is resembled with the noble gas configuration, but it is a strong oxidizing agent, as it is a reducing agent, oxidizing agent, as it quickly accepts electron and goes to the +3 oxidation state, which is the common one. So if I talk about the value, which is +1.74, although the reaction rate is very slow, but C4 is used as a good catalytic agent in the analytical process. Okay, our next thing is, so promethium, neodymium, terbium and Dy, they all show +4 oxidation state. So +3, so +4 is shown by this Ce, which is cerium, and these 4 elements. But this is not that much popular. You won't be asked exam questions from this, but this is important, your cerium 4 plus 3 plus conversion. Lastly, your europium 2 plus, it also has a 2 plus oxidation state. So by losing 2 electrons, it shows a F7 configuration, and hence the formation of this 2 plus ion is possible. However, again it is a strong reducing agent as it goes quickly into the +3 by donating electron, since it want to go to its common oxidation state of +3. Okay, and same can be told about the ytterbium 2+, because they donate electron and goes through the ytterbium 3+. Is it clear to you? So this is very, very important regarding your common oxidation states, which is +3, and some of the anomalies which is coming from the oxidation state that results in the half-filled or full-filled orbitals. So what about reactivity? So they are very highly reactive alkaline orbitals, and the general reactions are shown here. You can clearly see that it is quickly reacting with them to show a +3 oxidation state. So this was the thing that I was telling you about, that this minimalistic statement of +3 oxidation state is very, very important, because it is quickly going to the +3 oxidation state in each of this case. Here it is forming M2S3, so exchanging the covalency with each of them. So as sulfur has a covalency of 2, so that is gone on to the metal, and the metal's covalency of 3 is gone on to the sulfur. Next, same is said for MX3. Then here also, on reaction with water, it goes to the MaOH3, again a +3 oxidation state. Here on reaction with your carbon, it forms carbide. So this is something which is peculiar. Okay, moving on to the nitride. On exchanging the covalency, 3 is common, so it is converted into Mn for simplicity. And lastly, we have the formation of oxides, which again is showing a +3 oxidation state for the metal. Okay, lastly, regarding a small point, so what are misch metals? So they contain about 90 to 95% lanthanoid, and cerium is 40.5%, and lanthanum and niobium is 44%, and iron is 4.5%. So this 90% is coming from cerium, lanthanum and niobium, whereas 4.5% is coming from iron. Okay, lastly, the remaining small portion is coming from calcium carbonate, silicon, which is about 10.5%. And this misch metal is used in cigarette and gas lighter, toys, tanks and tracer bullets. Okay, so this was all about the lanthanoid. Now we will talk about the actinoids. Of course, they are containing 14 elements similar to the lanthanoid because the lengths are same, and they belong to the 5f series, since the 5f orbital is filled here. So they start from thorium and end up to lawrencium. What is the general electronic configuration? Again the same, only the principal quantum number has been changed, which is 5f 1 to 14, 6d 0 to 2, and lastly 7s2. So here it is not 6d 0 to 1, it is 6d 0 to 2. Got it? So to justify that, I will show you the electronic configuration of actinoids as well. Before that, let us talk about the properties. Again, they show a +3 oxidation state as your lanthanoid. Now, they can also show a variable oxidation state as compared to the lanthanoid, because the energy difference between the 5f, 6d and 7s orbital is very much less. So electrons can be removed from each of these orbital with almost same attempt. Got it? So they have a +3 oxidation state in general, and they are very strong reducing agent and very radioactive in nature. Next, they react with oxygen, halogen, hydrogen and sulfur just like your lanthanoids, meaning that they will form a 3 covalency. Okay. Moving on to the next properties of actinoids. So what about the atomic and ionic radii? So they decreases regularly across the series, and this is again due to the actinoid contraction. Similar to the lanthanoid, due to the 5f orbital, we have the actinoid contraction. So your allocation of electron to the 4f, 5f or 6d electron in the actinoid are much more uncertain. So here we have seen in the previous case of lanthanoid, there were some anomalies where electrons were going to the d, but those anomalies were less as compared to the actinoid that you will see right now, because the energy difference between the the shells is keep on decreasing. Okay, so if you consider the energy difference, suppose 1s and 2s are this much apart, then if you move from 2s to 3s, the energy difference becomes less, and this keeps on decreasing. As a result of this less energy difference between them, the anomaly in the electronic configuration is seen, because electron filling is based upon the energy difference according to the Abbo principle. If this energy is very minimal, then the energy order is violated. Okay, and that thing is resulting in the extreme variant electronic configuration of your actinoids. You will see it, it's very much in prominent. Moving on to the next. So what about the note? As I said earlier, so they have no contribution from the s orbital in case of fulfilled electrons or paired electrons, but they have something known as orbital contribution. So if in case it has both unpaired electron, and if it is a part of lanthanoid or actinoid, so they will have both orbital motion as well as spin magnetic moment. And in that case, you have to consider the orbital moment, angular momentum value as well. Now this formula is not that much important at all. Question does not comes from here, but from here you can just see that how the orbital is affecting the magnetic properties of this lanthanoid, which is not seen in the case of your D block elements, where we simply calculate the magnetic moment using the count of unpaired electron. Now this is used in the treatment of cancer, thorium. Lastly, we have the electronic configuration. Here you can see that the electronic configuration is very much variant, starting from the actinium, which is not a part of your inner transition element. Remember, lanthanoids and actinoids are not a part of your F block element, because here the F orbital is not filled at all. Got it? So they belong to the D block element or the inner transition element. Next, so this is the way, this is your uh, actinoid series. If you want to remember it, I can give you a funny mnemonic for that. So that is thode pehlwan unse nipto. Okay, and this is your last one. If I talk about you, so thode pehlwan unse nipto, then purane aam kam bikenge, then last one, California, in California, Einstein, Fermi, and Mendeleev got the Nobel Prize from Lawrence. Okay, so this is the way you can learn it. Again, I would repeat it. If you want, you can write it down. So it is थोड़े पहलवान उनसे निपटो, then पुराने आम कम बिकेंगे, and lastly, in California, Einstein, Fermium, Mendeleev got Nobel Prize from Lawrencium. Okay, so this was all about the theory part. So since we are lagging time, we will not move on to the questions right now. Thank you for joining the session. I hope you enjoyed it.
Hello students, welcome to this lecture. So today 40 days crash course day 24. So in this lecture we will discuss trigonometric functions and equations. So as you know, first we will discuss theory part and then we will practice some questions on this chapter. Okay, this is our disclaimer. So first see trend analysis. Okay, so how much importance this chapter in JEE that we will first see. So total questions from 2017 to 2024 is 16. Okay, and in JEE you can see at least one question has been asked from this chapter. Okay, and weightage of this chapter is 6%. Okay, so weightage of this chapter is good and you should learn this chapter very well. So first here see yearly question distribution. So in 2024 there one question asked, okay, and the topic area, that basically the question based one trigonometric identities, and here concept covered 918 degree, okay, the value of sine 18 degree and the value of sine 32 degree, and here you have to memorize some specific trigonometric values. Okay, in 2023 one question asked from this chapter and that based one trigonometric identities. Here are concept covered sine 2 theta, that is 2 sine theta into cos theta. Okay, then in 2022 there one question asked and the question based one trigonometric equations. Here asked the question general solution of sine theta equal to sine alpha. Okay, and then in 2021 one question asked and that question based one trigonometric function. In 2020 two question asked based one question asked based one trigonometric function, and then in 2019 two question asked based one trigonometric ratios of compound angles, and in 2017 one question asked based one trigonometric identities. Okay, and there was no question in 2018. And the difficulty level easy, average, okay, and difficult. So sometimes asks question easy, sometimes asks question average, sometimes question asks difficult. Okay, so you should learn this chapter very well. So let's see first here what we will cover in this lecture. So first here, first we will discuss angle on circular system. Okay, so what is angle on circular system, that first we will discuss. After that we will discuss trigonometric functions. So you all know some trigonometric functions like sine theta, cos theta, tan theta, sec theta, cosec theta. Okay, so we will discuss about these functions. Then we will discuss trigonometric identities. So you all know some trigonometric identities like sin square theta plus cos square theta equals 1, sec square theta minus tan square theta equal to 1. Okay, and cosec square theta minus cot square theta equal to 1. Okay, you will know these identities. So we will discuss about these identities. After that we will discuss trigonometric ratios. Okay, and we will discuss trigonometric ratios of functions of acute angles. Then we will discuss trigonometric ratios of compound and multiple angles. Okay, after that we will discuss transformation formula. So there are some transformation formula that we will use to solve any problems on trigonometric functions and equations, that we will discuss in this lecture. Then we will discuss conditional identities. Okay, then we will discuss maximum and minimum values, okay, of some trigonometric functions. Then we will discuss trigonometric equations, okay, like the equations that involve trigonometric functions, that is called trigonometric equations. So we will discuss about trigonometric functions. After that we will discuss what is principal solution. Okay, so suppose you have sine theta equals 1, then that case you have to find the principal value of sin theta equal to 1. Okay, that case you can find. Okay, so we will discuss principal solution. Then we will discuss general solution, and lastly we will discuss summation of some trigonometric series. Okay, and after that we will discuss some practice questions, one trigonometric functions and equations. Okay, so students, I hope you are ready to start. Okay, so let's start. First topic, angle on circular system. So let's discuss angle on circular system. So if the angle subtended by an arc of length L at the center of a circle of radius R. Okay, suppose you have a circle of radius R. Okay, and here the angle subtended by an arc of length L. Here the length of arc is L and the radius of the circle is R, and here the angle subtended is theta. Then what is the relation between theta, L and R? So the relation between theta, L and R is basically theta equal to L by R. Okay, so this relation is a very important relation. So you should keep in your mind this relation, theta equal to L by R. Theta is the angle subtended by an arc of length L at the center of a circle of radius R. Okay, clear? Then see, if the length of arc is equal to the radius of the circle. Okay, that means if L equal to R, then the angle subtended at the center of the circle will be 1 radian. So what is 1 radian? So if the length of arc is equal to the radius of the circle, that is L equal to R, then the angle subtended at the center of the circle will be 1 radian. Okay, so now see here how we denote it. So 1 radian is denoted by 1 to the power c. Okay, so this, by this symbol we denote 1 radian. So now you may ask, what is the relation of 1 radian and degrees? So 1 radian, this is equal to 57 degrees 16 minutes 22 seconds. Okay, this is approximately. So you should keep in your mind 1 radian, this is equal to 57 degrees 16 minutes 22 seconds. Clear? Then see this figure. So in this figure, this angle theta, so this angle theta is basically subtended by an arc of length. Here arc of length is L at the center of the circle of a circle radius R. Okay, here the radius R, here this angle is theta and the length of arc is L, and the relation between theta, L and R is basically theta equal to L by R. Okay students, is it clear to all of you? Now see here the conversion formula of radian to degrees and degrees to radian. Okay, so you should keep in your mind 2 pi radian is equal to 360 degrees. Okay, so 2 pi radian is equal to 360 degrees. So now tell me, 1 radian is equal to what? 2 pi radian is 360 degrees. Okay, so 1 radian, this is equal to 360 degrees by 2, 360 degrees by 2 pi. Okay, that is 180 degrees divided by 5. Okay, so 1 radian is equal to 180 degrees divided by pi. So if I ask you, what is 2 radian? Everyone give your answer. What is 2 radian in degrees? 2 radian is what in degrees? Everyone give write your answer in chat section. 2 radian is equal to how much degrees? Everyone write. So 2 radian, this is equal to 360 degrees divided by pi. Okay, similarly you can convert, suppose you have to convert 20 radian. Okay, so now convert 20 radian into degrees. So how much it is? Everyone give your answer and write your answer in chat section. 20 radian is equal to what? Use this formula. use this conversion formula. 1 radian is equal to 180 degrees divided by pi. Okay, use this conversion formula and find 20 radian. Everyone, write your answer in chat section. What is 20 radian is equal to in degree? Okay, give your answer. So here you see 1 degree, this is equal to pi by 180 radian. Okay, so if I ask you 30 degrees equal to what in radian? Everyone give your answer. 30 degrees equal to what in radian? Everyone give your answer. So 30 degree, okay, this is equal to what? 30 degree equal to pi by 180 times 30. Okay, that is equal to pi by 6 radian. Okay, so 30 degrees equal to pi by 6 radian. Now you will find 60 degrees equal to in radian. Okay, 60 degrees equal to in radian. Yes, I am good. Now find 60 degrees in radian. Everyone, find and give your answer in chat section. This conversion formula is very, very important. Okay, very, very important. So you should keep in your mind this conversion formula. Okay, so based on this conversion formula, you can convert from radian to degrees. Okay, and degree to radian. Okay, very useful and very important formula these are. Okay, good, very good. Now moving to the next. Now we will discuss some trigonometric functions. Okay, so first we let here x dash o x, this coordinate axis, and y o y dash, this coordinate axis. Okay, and here we are taking o as the center and a unit radius. Okay, unit radius means this circle with radius 1 unit. Okay, now draw a circle and cutting the coordinate axis at point a, b, a dash and b dash, that's shown in this figure. Okay, so in this figure you can see x dash o x, this is coordinate axis, this is x, this is called x axis. Okay, and y o y dash, this axis is called y axis. Okay, and here we taking o as the center and a unit radius, and then we have drawn a circle with 1 radius. Then here this circle cutting the coordinate axis x dash o x and y o y dash at the point a, b, a dash and b dash. Clear? Is it clear to all of you? Now we let here the point p x comma y. Okay, p x comma y be any point on the circle. Okay, so this is actually variable point. Here p x comma y be any point on the circle with angle AOP. This angle is theta. Okay, this angle is theta radian. And here length of arc AP. What is the length of arc AP? The length of arc AP is theta. Why? Because you know 1 radian, when we call 1 radian, when length of arc and the theta, the angle subtended by the circle with radius r, both are equal. That means L equal to theta. Okay, r equal to theta. Okay, radius and angle both are equal. So r equal to theta, then that is 1 radian. So here arc AP is basically theta. Clear? So we let first px comma y any point on the circle, and here the angle AOP is theta and the length of arc is theta. Clear? Everyone clear? Now then the 6 trigonometric functions can be defined as, so you all know 6 trigonometric functions like cos theta, sin theta, tan theta, sec theta, cosec theta, okay, cot theta, that etc. So cos theta is basically here OM divided by OP. Okay, so you can see here this triangle is basically right angle triangle. Okay, this angle is 90 degree. Angle PMO is 90 degrees, and here base is x. Okay, OM is base and OP is hypotenuse. Okay, so cos theta equal to OM divided by OP. Here OM is x unit and OP is 1 unit. So cos theta equal to x by 1 equal to x. Clear? Then sin theta, this is equal to PM divided by OP. Okay, so this is perpendicular and this is hypotenuse. So sin theta equal to PM of over OP. Here PM is equal to y and OP is 1 because this circle with radius 1 unit. Okay, so OP is 1 always. So sin theta equal to PM over OP equal to y. Then similarly you can find sec theta. So sec theta equal to basically OP divided by OM. So you all know sec theta is basically reciprocal function of cos theta. Okay, so cos theta is OM over OP. So sec theta equal to OP over OM. So cos theta equal to x. So sec theta equal to 1 by x. Here x should be not equal to 0. Why? Because if you take x is 0, then that case sec theta is not defined because 1 by 0 is not defined. This is undefined. Okay. Then see cosec theta. Cosec theta is basically reciprocal function of sin theta. Okay. So sin theta is y. So cosec theta equal to y 1 by y. And here y is not equal to 0. Then see tan theta. Tan theta equal to perpendicular divided by base. So PM divided by OM. So this is equal to y by x. Here x is not equal to 0. Then cot theta, this is equal to basically reciprocal of tan theta. Okay, so cot theta equal to OM over PM. This is equal to x by y. Here y is not equal to 0. Clear? So this is how we define 6 trigonometric functions. So you should keep in your mind these 6 trigonometric functions. Okay, these are very important and basic trigonometric functions. So you should keep in your mind these. Clear? Everyone clear? These are so basic. Okay, very simple. You will know. I hope I know you will know this. Okay, you will know these 6 trigonometric functions. Now moving to the next. Now we will discuss some trigonometric identities. So as I told you, we will discuss some trigonometric identities. Okay, you all know some trigonometric identities like sin square theta plus cos square theta equal to 1, sec square theta minus tan square theta equal to 1. Okay, cosec square theta minus cot square theta equal to 1. Okay, now when we call an equation involving trigonometric functions is trigonometric identity. So an equation involving trigonometric functions which is true for all those angles for which the functions are defined. Okay, this equation is called trigonometric identity. Clear? So here some identities are given in below. So see here, first identity sin square theta plus cos square theta equal to 1. So here you can see for all those angles for which the function sin theta and cos theta are defined, this equation sin square theta plus cos square theta, okay, equal to 1. This is actually trigonometric identity. This identity is very important identity. Okay, and I know you will know this identity and you frequently use this identity to solve many problems, one trigonometric functions and equations. Next identity is sec square theta minus tan square theta equal to 1. Okay, this is also very important identity. We frequently use this identity to solve the question involved sec theta and tan theta. Okay, and then third trigonometric identities, that identity that is cosec square theta minus cot square theta equal to 1. Okay, so these are some identities which are very useful and important in the point of view of examination. Okay, so you should keep in your mind these 3 identities. Clear? So if it's clear, then please write in chat section CLR. Okay, and you should prove these identities. How we obtain these identities, that you should verify. Okay, so everyone you will verify these identities later, okay, after finishing this class. So everyone, please keep in your mind now these identities, okay, and next later you will verify how we obtain these identities. Clear? Now moving to the next. Now we will discuss some trigonometric ratios of functions of acute angles. So you will know when we call an angle acute angles, when angle is less than 90 degrees, okay, then that angle is acute angle, like 0 degree, 60 degree, 30 degree, okay, and so on. So the ratios of the sides of a triangles with respect to its acute angles are called trigonometric ratios or T ratios. Okay, this is also called T ratios or trigonometric ratios. Okay, and the ratios are, you know, if we have right angle triangle, okay, and there the ratios of sides of a triangle with respect to the acute angles, these are called trigonometric ratios, like sin theta, cos theta, tan theta, cosec theta, sec theta, okay, cot theta. So see here this figure, this is our right angle triangle. Okay, in this triangle, this side is perpendicular, this side is hypotenuse, and this side is base. Okay, and now see, we will see the relation of the sides of a triangle with respect to its acute angle theta. Okay, and here we will define the trigonometric ratios or T ratios. Okay, so in a right angle triangle ABC, this angle CAB is theta, okay, and this angle CBA is 90 degrees. Okay, this angle is 90 degree. Okay, this is right angle triangle. Then sin theta, this is equal to perpendicular divided by hypotenuse. Okay, so that is sin theta equal to BC upon AC. Then cos theta, this is equal to base divided by hypotenuse. Okay, that is AB upon AC. And tan theta equal to BC divided by AB, that is perpendicular divided by base. And cosec theta, this is reciprocal of sin theta. So cosec theta equal to 1 by sin theta. Sin theta is base BC upon AC. So cosec theta is AC upon BC. And this is equal to hypotenuse divided by perpendicular. Clear? Now moving to the next. Then sec theta is reciprocal of cos theta. So sec theta equal to 1 by cos theta. So cos theta is AB upon AC. So 1 by cos theta equal to AC upon AB. Okay, and this is actually hypotenuse divided by base. Then cot theta is reciprocal of tan theta. So cot theta equal to 1 by tan theta. This is equal to AB upon BC. Why? Because you know tan theta equal to BC upon AB, that is perpendicular divided by base. So cot theta equal to base upon perpendicular. Clear? It's clear? I hope it's clear to all of you. Very simple. Okay, and you will know about these trigonometric ratios. Very basic trigonometric ratios. You will know about this. Okay. Now moving to the next. Now we will see sign for trigonometric ratios in 4 quadrants. Okay. So you will know we have 4 quadrants: quadrant 1, first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay. So 0 to 90 degrees, that is first quadrant. 90 degrees to 180 degrees, that is second quadrant. 180 degrees to 270 degrees is third quadrant, and 270 degrees to 360 degrees is fourth quadrant. Okay. Now we will see the sign for trigonometric ratios. That means the sign of sin theta, cos theta, tan theta, sec theta, cosec theta, cot theta in 4 quadrants. Clear? So see here in first quadrant, that is 0 to 90 degrees. Here the sin theta is positive, cos theta is positive, tan theta positive, cot theta positive, sec theta positive, cosec theta positive. That means in first quadrant all the trigonometric ratios are positive. Okay. So if your theta lies between 0 to 90 degrees, then that case the sign for trigonometric ratios in in this quadrant up is positive. Okay. In second quadrant, that is 90 degrees to 180 degrees. Okay. So if your theta lies between 90 degrees to 180 degrees, then here in this quadrant sin theta is positive, cos theta negative, tan theta negative, cot theta negative, and sec theta is negative and cosec theta is positive. Okay, so in second quadrant, sin theta and cosec theta positive, but other trigonometric ratios like cos theta, tan theta, cot theta, sec theta are negative. Okay, in third quadrant, that is 180 degrees to 270 degrees. In this quadrant, sin theta negative, cos theta negative, tan theta positive, cot theta positive, sec theta negative, and cosec theta negative. Okay, so in third quadrant, you should keep in your mind tan theta and cot theta positive, and other trigonometric ratios like sin theta, cos theta, sec theta, cosec theta are negative. Clear? In fourth quadrant, that lies between 270 degrees to 360 degrees. Okay, so when your theta between 270 degrees to 360 degrees, then sin theta is negative, cos theta positive, tan theta negative, cot theta negative, sec theta positive, cosec theta is negative. Okay, so in fourth quadrant, you should keep in your mind cos theta and sec theta positive. Okay, and other trigonometric ratios like sin theta, cos theta, tan theta, cosec theta are negative. Okay, so keep it in sorts. So in first quadrant, all are positive. In second quadrant, sin theta and cosec theta positive, all other are negative. Okay, in third quadrant, tan theta and cot theta are positive and all others are negative. In fourth quadrant, cos theta and sec theta positive and all others are negative. Clear? Is it clear to all of you? Everyone, you can remember, you can keep in your mind these sign for trigonometric ratios in 4 quadrants. If it clears, then write in chat section clear. Okay, everyone. So I can move to the next. Okay, is it clear to all of you? Is it clear to all of you? So you should keep in your mind these sign for trigonometric ratios in 4 quadrants. Okay, this is very important and very useful to when we will find the value of sin theta, cos theta, tan theta, cot theta, sec theta, and cosec theta in 4 quadrants. Clear? Okay, I think it's clear to all of you. Now moving to the next. Now we will discuss some useful values of trigonometric ratios of some useful angles between 0 degree and 90 degrees. Okay, so between 0 degree to 90 degrees, there we have some useful angles. At that values, we will see the value of trigonometric ratios like sin theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. Okay, so see this figure, see this table. Okay, so in this table, we have some useful angles like 0 degree, 15 degrees, 22.5 degrees, 30 degrees, 36 degrees, 45 degrees, 54 degrees, 60 degrees, 67.5 degrees, 72 degrees, 75 degrees, and 90 degrees. Okay, and there at their values, okay, we have the corresponding values of sin theta, cos theta, tan theta, cot theta, sec theta, and cosec theta. Okay, these are very useful. Okay, these are very useful, and we frequently use these values at these useful angles. Okay, of the trigonometric ratio sin theta, cos theta, tan theta, cot theta, sec theta, cosec theta. Okay, so you all know the value of sin 0 degree is 0. Okay, cos 0 degree is 1, tan 0 degree is 0, cot 0 degree is infinity. Why? Because cot theta is reciprocal of tan theta. Okay, and sec theta is 1 because sec theta is reciprocal cos theta. So cos 0 degree is 1, so sec 0 degree is 1. Then cosec 0 degree is infinity. Why? Because you know sin 0 degree is 0 and cosec theta is 1 by sin theta. So sin theta is 0, sin 0 degree is 0, so 1 by 0 is infinity. Clear? Then see here in sin at angle 15 degree. So at angle 15 degrees, the sin 15 degrees is root 6 minus root 2 upon 4. So you can verify, okay, using the formula of cos 2 theta. Okay, that we will discuss later. Okay, so just at this time keep in your mind. Okay, so you should keep in your mind and you should note these trigonometric ratios of some useful angles between 0 degree to 90 degrees. Okay, these are very useful. We will use to solve many problems in this chapter. Okay, So you should keep in your mind of sine 15 degrees, the value of sine 15 degrees, cos 15 degrees, tan 15 degrees, cot 15 degrees, sec 15 degrees, then cosec 15 degrees. Okay. Then you should keep in your mind sine 22.5 degrees. Okay, this value is for sine 22.5 degrees. Then this is cos 22.5 degrees. This is tan 22.5 degrees. This is cot 22.5 degrees. Then this is sec 22.5 degrees, and this value is for sin cosec 22.5 degrees. Okay. Similarly, you can see for 30 degrees, you all know for angle 30 degrees, you know sine 30 degree is 1 by 2, okay, and cos 30 degrees is root 2 upon 2, and tan 30 degrees 1 by root 3, tan 30 degrees 1 by root 3, and cot 30 degrees root 3, okay. Then sec 30 degrees 2 by root 3, and cosec 30 degrees 2. Similarly, you can find for 36 degrees, 45 degrees, 54 degrees, okay, 60 degrees, 67.5 degrees, 72 degrees, 75 degrees, and 90 degrees. So note these trigonometric ratios of some useful angles between 0 to 90 degrees and keep in your mind. Okay, very important. You can take a note on this table, very important table. Okay, here we have the values of trigonometric ratios at 0 degree, 15 degrees, 22.5 degrees, 30 degrees, 36 degrees, 45 degrees, 54 degrees, 60 degrees, 67.5 degrees, 72 degrees, 75 degrees, and 90 degrees. Clear? So keep in your mind this table. Okay. Now moving to the next. Now we will see trigonometric ratios of allied angles. Okay. So you all know when theta, you have sin theta, cosec theta, cos theta, sec theta, tan theta, cot theta. Okay. When you take minus theta, then sin of minus theta is what? Minus sin theta. Okay. Sin of minus theta is minus sin theta. Cosec of minus theta is minus cosec theta. Cos of minus theta is cos theta. Okay. Here cos of minus theta and cos theta both are equal. Cos theta equal to cos of minus theta. Then sec of minus theta is sec theta. Sec of minus theta equal to sec theta. Tan of minus theta equal to minus tan theta. Cot of minus theta equal to minus cot theta. Okay. That means sine function is odd function. Okay. You will know the definition of odd function. So if f of minus x equal to minus f of x, then the function f of x is odd function. So here sine of minus theta, this is equal to minus sine theta. So sine function is odd function. Okay. Similarly, cosec function is odd function, and tan function is odd function, and cot function is also odd function. Okay. But cos function and sec function is even function, because you can see here f of minus x equal to f of x. Cos of minus theta equal to cos theta. So f of x equal to minus f of minus x. Okay. So here the function cosine function is even function. Similarly, second function, also sec theta, is even function. Clear? Understand? I hope you all understand. Now, see here, what is cos of 90 degrees minus theta? What is cos of minus 90 degrees minus theta, and what is sine of 90 degrees minus theta? What is sine of 90 degrees minus theta? So, if we take 90 degrees minus theta, this angle, then sine of 90 degrees minus theta, this is equal to cos theta. Okay. You can see sine 90 degrees minus theta, this lies between 0 to 90 degrees. Okay. That means this angle lies on first quadrant. Okay. And you will know in first quadrant all the trigonometric ratios are positive. Okay. So sine of 90 degrees minus theta, this is equal to cos theta. Then cosec of 90 degrees minus theta is equal to sec theta. Then cos of 90 degrees minus theta equal to sin theta. Then sec of 90 degrees minus theta equal to cosec theta. Then tan of 90 degrees minus theta equal to cot theta. Cot of 90 degrees minus theta equal to tan theta. Okay. Clear? Now, if I find sine of 90 degrees plus theta, so sine of 90 degrees plus theta, this is equal to cos theta. Why? You can see here you can use sine of a plus b formula. Okay. That we will discuss later. Okay. So just at this time, you should keep in your mind sine of 90 degrees plus theta equal to cos theta, cosec of 90 degrees plus theta equal to sec theta, cos of 90 degrees plus theta equal to minus sin theta, sec of 90 degrees plus theta equal to cosec theta, tan of 90 degrees plus theta equal to minus cot theta, and cot of 90 degrees plus theta equal to minus tan theta. Okay, and then see here at 180 degrees minus theta, here sin theta, then cosec theta, cosec of 180 degrees minus theta equal to cosec theta, cos of 180 degrees minus theta equal to minus cos theta, sec of 180 degrees minus theta equal to minus sec theta. Okay, and similarly you can see tan of 180 degrees minus theta equal to minus tan theta, cot of 180 degrees minus theta equal to minus cot theta. Okay, then you can see here sine of 180 degrees plus theta equal to minus sin theta. Okay, and similarly you can see here for cosec theta, cos theta, sec theta, tan theta, and cot theta. Then find sine of 270 degrees minus theta, this is equal to minus cos theta, cosec of 270 degrees minus theta equal to minus sec theta, and you can see cos of 270 degrees minus theta equal to minus sin theta. Okay, and you can see for other. Okay, and for at angle 270 degrees plus theta, you can see sine function, sine theta, cosec theta, cos theta, sec theta, tan theta, and cot of theta. Okay, and similarly sine of 360 degrees minus theta equal to minus sin theta, cosec of 360 degrees minus theta equal to minus cosec theta, cos of 360 degrees minus theta equal to cos theta, sec of 360 degrees minus theta equal to sec theta, and tan of 360 degrees minus theta equal to minus tan theta, then cot of 360 degrees minus theta equal to minus cot theta. Okay, so you should keep in your mind these trigonometric ratios of allied angles. Okay, at minus theta, at 90 degrees minus theta, at 90 degrees plus theta, at 180 degrees minus theta, and 180 degrees plus theta, 270 degrees minus theta, and 270 degrees plus theta, and 360 degrees minus theta. Okay, so you should keep in your mind these trigonometric ratios of allied angles. So I hope you will understand. Now moving to the next. Now we will discuss some trigonometric ratios of compound and multiple angles. Okay, this is very interesting, and here we will discuss some important formulas. Okay, so see here first compound angles. So sine of a plus b, this is equal to sine a times cos b plus cos a times sin b. Okay, this is very important and useful formula. Okay, for finding like sine of 15 degrees. Okay, sine of 15 degrees, there you you can use a sine of a minus b formula. Okay, that we will discuss later. That because here there will be minus sign. If you find sine 90 degrees value, okay, that case you can write sine of 60 degrees plus 30 degrees, and then if you apply this formula, then you will get the value of sine of 90 degrees. Okay, then sine of a minus b, this is equal to sine a into cos b minus cos a into sin b. Okay, this is also very important formula. Then third, you have cos of a plus b, this is equal to cos a cos b minus sin a sin b. When you have here positive, then here you will have negative sign. Okay, so when you have cos of a plus b, this is equal to cos a into cos b minus sin a into sin b. So you should keep in your mind. Then cos of a minus b, this is equal to cos a into cos b plus sin a into sin b. Okay, when you have here negative sign, then here it will be positive sign. Okay, this is how you can remember, you can keep in your mind. Then tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Okay, you will know about this formula, very important formula, and frequently we use these formulas. Okay, then tan of a minus b, this is equal to tan a minus tan b divided by 1 plus tan a into tan b. So when you have tan of a plus b, then that case here in numerator you have tan a plus tan b, in denominator you have 1 minus tan a into tan b. Okay, and when you have tan of a minus b, then you have in numerator tan a minus tan b, in denominator you have 1 plus tan a into tan b. Clear? Then cot of a plus b, this is equal to cot a into cot b minus 1 divided by cot a plus cot b. When you have cot of a plus b, then you have in numerator cot a into cot b minus 1, and in denominator you have cot a plus cot b. And cot of a minus b, this is equal to cot a into cot b plus 1 divided by cot b minus cot a. Okay, when you have here negative sign, then in numerator you have cot a into cot b plus 1, in denominator you have cot b minus cot a. Then see here another compound angles formula, that is 1 plus tan A divided by 1 minus tan A. This is equal to tan of pi by 4 plus A. How you can prove it? Here you can use this formula, tan of A plus B, this is equal to tan A plus tan B divided by 1 minus tan A into tan B. Okay, and you will know tan 45 degrees, that is tan of pi by 4 equal to 1. Okay, you will know about this. So you can, if you use this formula, then you can prove 1 plus tan A divided by 1 minus tan A, this is equal to tan of pi by 4 plus A. Clear? It's clear? Then see 1 minus tan A divided by 1 plus tan A, this is equal to tan of pi by 4 minus A. Okay, you can prove similarly by using this formula, tan of A minus B, this is equal to tan A minus tan B divided by 1 plus tan A into tan B. Okay, so these are some compound angles formula. Okay, so you should keep in your mind these formulas. These are very important formula. Okay, and we frequently use these formulas to solve problems 1, trigonometric functions and equations. Okay, clear? It's clear to all of you? I think it's clear. Actually, we discuss here just formulas. Okay, and you have to verify these formulas, how we obtain these formulas. Okay, that you have to verify. So please verify these formulas of compound angles. Okay, now moving to the next. Now we will discuss trigonometric ratios of multiple angles. Okay, so you have sine 2a. Okay, if you have a double angle, okay, sine 2a, this is equal to 2 sine a into cos a. Okay, and you will know sine 2a, this is equal to also 2 tan a divided by 1 plus tan square a. Okay, and second we have cos 2a formula, that is cos square a minus sin square a. Okay, and this is equal to 1 minus tan square a divided by 1 plus tan square. And you can also write this formula as 2 cos square a minus 1. Okay, and this is also equal to 1 minus 2 sin square a. Okay, this formula is very important. We use so many times when solving problems. Okay, on this chapter. So cos 2a equal to 2 cos square minus sin square, and this is equal to 1 minus tan square divided by 1 plus tan square, and this is equal to 2 cos square minus 1. This is equal to 1 minus 2 sin square a. Clear? Then see here tan of 2a. Tan 2a, this is equal to 2 tan a divided by 1 minus tan square. Okay, you can write tan 2a as tan of a plus a. Okay, and then you can use tan of a plus b formula, that is tan a plus tan b divided by 1 minus tan a into tan b. Okay, so if you use this formula, then you can easily prove tan 2a equal to 2 tan a divided by 1 minus tan square a. Clear? Then see sin 3a formula. So sin 3a, this is equal to 3 sin a minus 4 sin cube a. Okay, so you can remember like this, sin 3a, this is equal to 3 times sin a minus 4 times sin cube a. Here we multiply 3 with the sin a function. Okay, and here minus sign, then we multiply 4 with sin cube a. Then cos 3a, this is equal to 4 times cos cube a minus 3 cos a. Tan 3a, this is equal to 3 tan a minus tan cube a divided by 1 minus 3 tan square a. Okay, and we can prove it by using tan of a plus b formula, that is tan a plus tan b divided by 1 minus tan a into tan b. Okay, and then we can use also tan 2a formula, that is 2 tan a divided by 1 minus tan square a. Okay, by using that we can prove tan 3a, this is equal to 3 tan a minus tan cube a divided by 1 minus 3 tan square a. Clear? These are very important formulas. Okay, so you should keep in your mind these formulas also. Okay, now moving to the next. Now we will discuss some transformation formula. Okay, so when you have 2 sin a cos b, then how can we transfer as sum? So 2 sin a into cos b, this is equal to sin of a plus b plus sin of a minus b. So you all know the formula of sin of a plus b, that is sin a into cos b plus sin b into cos a. Okay, and sin of a minus b formula is basically sin a into cos b minus sin b into cos a. Okay, if you using this formula, then you can easily prove from right hand side to left hand side. Okay, that is you can prove RHS equal to LHS. So you can prove 2 sin a into cos b equal to sin of a plus b plus sin of a minus b. Clear? Then 2 cos a into sin b, 2 cos a into sin b, if you subtract sin of a minus b from sin of a plus b, then you only get 2 cos A into sin B. Okay, by using the formula sin of A plus B equal to sin A into cos B plus sin B into cos A, and sin of A minus B equal to sin A into cos B minus sin B into cos A. Okay, so if you using this formula, and then you can prove from RHS to LHS. Okay, RHS equal to LHS. Then see here, 2 cos A into cos B, this is equal to cos of A plus B plus cos of A minus B. Here you can use the formula cos of A plus B equal to cos A into cos B minus sin A into sin B. Okay, and cos of A minus B equal to cos A into cos B plus sin A into sin B. Okay, using this formula you can, so this is equal to 2 cos A into cos B. Clear? Then say 2 sin A into sin B, this is equal to cos of A minus B minus cos of A plus B. So you can use here cos of A minus B formula, that is cos A into cos B plus sin A into sin B, and cos of A plus B formula is cos A into cos B minus sin A into sin B. Okay, then you can prove from RHS to LHS. So RHS equal to LHS. So 2 sin A into sin B equal to cos of A minus B minus cos of A plus B. Then see sin C plus sin D. Okay, so suppose you have sin C plus sin D, then how can we prove, how can we so this is equal to 2 sin C plus D upon 2 into cos of C minus D by 2. Okay, in this case use the above formula. Okay, this formula you can use and you can prove sin C plus sin D equal to 2 sin of C plus D by 2 into cos of C minus D upon 2. Clear? Understand? Similarly, sin C minus sin D, this is equal to 2 cos of sin C plus D by 2 into sin of C minus D by 2. Okay, so here in this case you can use this formula. This formula you can use 2 cos A into sin B equal to sin of A plus B minus sin of A minus B. In this case, first you take A plus B as C and A minus B as D. Then you can prove this sin C minus sin D equal to 2 cos of C plus D by 2 into sin of C minus D by 2. Understand? Then cos C plus cos D, this is equal to 2 times cos of C plus D by 2 into cos of C minus D by 2. Here you can use this formula. 2 cos A into cos B equal to cos of A plus B plus cos of A minus B. Okay, and here in this case A plus B equal to C and A minus B equal to D, and then solve these two equations and find the relation of cos C plus cos D equal to 2 cos of C plus D by 2 into cos of C minus D by 2. Understand? Then see cos C minus cos D, this is equal to minus 2 times sin of C plus D by 2 into sin of C minus D by 2. Then sin of A plus B into sin of A minus B. Okay, so when you have sin of A plus B, you have angles A plus B and A minus B. Okay, of sin function. Sin of A plus B into sin of A minus B. This is equal to simply sin square A minus sin square B. Okay, you can prove by using the formula of sin of A plus B, that is sin A into cos B plus sin B into cos A. Okay, and sin of A minus B, that is equal to sin A into cos B minus sin B into cos A. Okay, if you use this formula, then you can prove this is equal to sin square A minus sin square B. Okay, so try it and verify how we obtain these formulas. Okay, everyone. Then say cos of A plus B times cos of A minus B, this is equal to cos square A minus sin square B. Okay, similarly you can prove this. Then cos A into cos 2A into cos 4A into cos 8A times dot 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 cos of 2 to the power n minus 1A, this is equal to simply 1 by 2 to the power n times sin A times sin of 2 to the power n times A. This is very important formula. Best one this formula. Many questions asked in JEE previous year question. Okay, you can see in JEE previous year question, this formula used many times, frequently use this formula. Very important formula, very important formula. You should keep in your mind this formula. Okay, so these all formulas are very useful and important. Okay, and this formula is very important formula. So you should keep in your mind cos A into cos 2A times cos 4A times cos 8A times dot 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 cos of 2 to the power n minus 1 times A. This is equal to sin of 2 to the power n times A divided by 2 to the power n times sin A. Clear? Understand? So I hope you will understand this formula. Okay, and your task, your homework, you have to verify how we obtain these formulas. Okay, everyone, you will try how we obtain these formulas. Okay, and you should keep in your mind these formulas. Okay, and you have to make on short notes to revise these formulas. Okay, so write in these formulas into your notebooks. Okay, and revise that formulas daily basis. Clear? Understand? Now moving to the next. Now we will discuss some conditional identities. Okay, so if the sum of angle A, B and C, that is A plus B plus C equal to 180 degrees, then what can we say? Then sin 2A plus sin 2B plus sin 2C, this is equal to 4 times sin A, sin B, sin C. You can verify. Okay, so please verify this later. Then cos 2A plus cos 2B plus cos 2C, this is equal to minus 1 minus 4 times cos A, cos B, cos C. Okay, you can also verify this. And sin A plus sin B plus sin C equal to 4 times cos of A by 2 into cos of B by 2 into cos of C by 2. Then cos A plus cos B plus cos C, this is equal to 1 plus 4 times sin of A by 2 plus into sin of B by 2 into sin of C by 2. Then tan A plus tan B plus tan C, this is equal to tan A into tan B into tan C. This is very important formula. Okay. And tan of A by 2 into tan of B by 2 plus tan of B by 2 into tan of C by 2 plus tan of C by 2 into tan of A by 2. This is equal to 1. Okay. So sometimes based on this formula, directly question asked. Okay. So you should keep in your mind these formulas and you have to verify how we obtain these formulas. So you have basically A plus B plus C equal to 180 degrees. Using this, you have to show these conditional identities. Clear? Understand? So you should keep in your mind these conditional identities and you should verify how we obtain these conditional identities. Clear? Now moving to the next. Now we will discuss an important topic, maximum and minimum values. Okay, so you all know sin x is between minus 1 to 1. That means minus 1 less than equal to sin x less than equal to 1. Okay, so you can write modulus of sin x is less than equal to 1. Okay, and you all know when you have minus 1 less than equal to x less than equal to 1, then that case we write mod of x is less than equal to 1. So here minus 1 is less than equal to sin x less than equal to 1. So we can write mod of sin x is equal less than equal to 1. Clear? Then see minus 1 is less than equal to cos x less than equal to 1. So we can write mod of cos x is less than equal to 1. Understand? Then mod of sec x is greater than equal to 1. Okay, and mod of cosec x is greater than equal to 1. You all know. Okay, and tan x, cot x take all real values. So you should keep in your mind tan x and cot x, these two functions takes all real values. And now note there's some importance points like maximum value of a cos theta plus minus b sin theta. So what is the maximum value of a cos theta plus minus b sin theta? Okay, so you should keep in your mind the maximum value of a cos theta plus minus b sin theta is equal to square root of a square plus b square. Okay, so when you have the function 2 cos theta plus and minus 3 sin theta, so what will be the maximum value of 2 cos theta plus minus 3 sin theta? Everyone write your answer in chat section. What is the maximum value of 2 cos theta plus and minus 3 sin theta? Give your answer in chat section. Everyone try it. Everyone try it and give your answer in chat section. What is the maximum value of 2 cos theta plus minus 3 sin theta? Give your answer in chat section. Everyone give your answer in chat section. What is the maximum value of 2 cos theta plus and minus 3 sin theta? Very simple, very easy. Okay, just use here the formula. Okay, by using this formula you can easily find the maximum value of 2 cos theta plus or minus 3 sin theta. Give your answer. Everyone give your answer. Very simple. Just first of all you have to identify the value of a, okay, and the value of b. Here the value of a is what? A is 2, okay, and b is 3. So if we put the values of a and b in the formula square root of a square plus b square, then you will get square root of 2 square plus 3 square, that is square root of 13. Okay, very good, very good, very good. Now move to the next. Now if we have the expression a cos theta plus and minus b sin theta, then the minimum value of a cos theta plus or minus b sin theta, this is equal to minus of square root of a square plus b square. Okay, just here when you are asking to find the minimum value of a cos theta plus minus b sin theta, then just you take here minus sign. Okay, you take just here minus sign of square root of a square plus b square. Clear? Understand? When you have you are asking find the maximum value of a cos theta plus minus b sin theta, then you take positive square root of a square plus square. When you are asking minimum value of a cos theta plus minus b sin theta, that is minus square root of a square plus b square. Okay, good. Then maximum value of a cos theta plus minus b sin theta plus c. Okay, so in the above expression there we have only a cos theta plus minus b sin theta. Okay, but now if we have a cos theta plus minus b sin theta plus c. Okay, so if we have if you if it added a constant c, okay, a cos theta plus minus b sin theta plus c, then the maximum value of the expression a cos theta plus minus b sin theta plus c, this is equal to c plus square root of a square plus b square. Okay, hello, yes, good. Okay, now see here, find the maximum value of 2 cos theta plus 3 sin theta plus 5. Everyone, give your answer. What is the maximum value of 2 cos theta plus 3 sin theta plus 5? Everyone, give your answer in chat section. Everyone, give your answer. You have the expression 2 cos theta plus 3 sin theta plus 5. Okay, you have 2 cos theta plus 3 sin theta plus 5. Okay, so just you have to here you have to first find square root of a square plus b square. Okay, so square root of a square plus b square is square root of 13. If you now add 5 with square root of 13, then you will get maximum value of a cos theta plus 2 cos theta plus 3 sin theta plus 5. Okay, that is 5 plus square root of 13. Clear? Understand? Not 1. Okay, 5 plus square root of 13. Then similarly, minimum value of a cos theta plus minus b sin theta plus c. Okay, this is equal to c minus square root of a square plus b square. Okay, that case you have to subtract square root of a square plus b square from the constant c. Okay, then you will get the minimum value of a cos theta plus minus b sin theta plus c. Understand? So if you have the function 2 cos theta plus 3 sin theta plus 5, then your minimum value of 2 cos theta plus 3 sin theta plus 5 is equal to 5 minus square root of 13. Understand? Clear? I hope you will understand. Okay, and now moving to the next. Now we will discuss trigonometric equations. So what is trigonometric equations? So when we call an equation is trigonometric equation, so an equation involving one or more trigonometrical ratios of unknown angle. Okay, so you have unknown angle and you have one or more trigonometric ratios, and if we take the equation involving these trigonometrical ratios of unknown angle, then that equation is called a trigonometrical equation. Okay, that called trigonometric equations. For example, you can take sin theta plus cos square theta equal to 0. Okay, in this equation you can see this equation involving sin theta and cos theta, these two trigonometric ratios, okay, of unknown angle theta. So this equation is an example of trigonometric equation. Understand? I hope you will understand. This is a trigonometric functions and equations chapter. Okay, now moving to the next. Now we will discuss principal solution. When a solution we call principal solution. So the value of the unknown angle, that is say theta. Okay, so here we are taking the angle theta, and this theta satisfies that trigonometric equation, and this equation is known as principal solution if theta is between 0 to 2 pi. Okay, when you take 0 less than equal to theta less than 2 pi, then the value of the unknown angle theta which satisfies the trigonometric equation is known as principal solution. Understand? So you will understand. I hope you will understand what is principal solution. So when your theta is between 0 to 2 pi, that means 0 less than equal to theta less than 2 pi, then the value of the theta that satisfies the trigonometric equation is known as principal solution. Now let's take an example. In this example, we have to find the principal solution of the equation sin theta equal to 1 by 2. So everyone find the principal solution of the equation sin theta equal to 1 by 2 and give your answer in chat section. Everyone try it and give your answer in chat section. What is the principal solution of the equation sin theta equal to 1 by 2? Everyone give your answer. Please give your answer and write your answer in chat section. What is the principal solution of the equation sin theta equal to 1 by 2? Everyone give your answer. Very simple. So let's see how to solve this. So let's start the solution here. So we know that first we know sine 30 degrees. This is equal to 1 by 2. Okay, we will know the value of sine of 30 degrees is 1 by 2. So the principal solution is theta equal to 30 degrees, that is pi by 6 also. Okay, we can also write in radian pi by 6. In degrees we can write 30 degrees. Okay, this value lies between 0 to 2 pi. So this is actually principal solution of the equation sin theta equal to 1 by 2. Clear? Understand? I hope you will understand. Now moving to the next. Now we discuss general solution. Okay, so since trigonometric functions are periodic function, you will know. Okay, as you know, period of sine function is 2 pi. Okay, and solution of trigonometric functions can be generalized. Okay, can be generalized with the help of the periodicity of the trigonometrical functions. Okay, so that solution is called general solution. So the solution consisting all possible solution of a trigonometric equation is called its general solution. Okay, understand? Now moving to the next. Now see here some general trigonometric equations and their solutions. Okay, so here you can see when you have the equation sin x equal to sin alpha. Here alpha is lies between minus pi by 2 to pi by 2. Okay, minus pi by 2 to pi by 2. Here the solution, general solution is x equal to n pi plus minus 1 to the power n times alpha. Okay, here n is from set of integers. Then cos x equal to cos alpha. You have the equation, this equation, trigonometric equations. Okay, and here 0 less than equal to alpha less than equal to pi. And the general solution for this equation is x equal to 2n pi plus and minus alpha, and here n is belongs in set of integers. Then if you have tan x equal to tan alpha, this equation, then here minus pi by 2 less than alpha less than pi by 2. Here x is equal to n pi plus alpha. Here n is belongs in set of integers. Okay, so if you have sin square x equal to sin square alpha, then x is equal to n pi plus minus alpha. N is from set of integers. Then cos square x equal to cos square alpha. This is this from here you get the general solution x equal to n pi plus minus alpha. Here n is from set of integers. Okay, when you have tan square x equal to tan square alpha, then you have x equal to n pi plus minus alpha. Here n is from set of integers. So you should keep in your mind these equations and their general solution. These are very important when we have trigonometric equations and then we have to find general solution. So that case you have to use these formulas. Okay, you have to use their solutions. Okay, like this we find this like this. So these are very useful and important, so you should keep in your mind. Now see here summation of some trigonometric series, very important. So here first see here the first summation of trigonometric series sin alpha plus sin of alpha plus beta plus sin of alpha plus 2 beta plus dot 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 to n terms. Okay, so if we have summation of summation of this series, okay, then what actually formula of this series, how can we find this is equal to sin of n beta by 2 divided by sin of beta by 2 times sin of alpha plus n minus 1 times beta by 2. Okay, so this is simply equal to this is okay, very simple, you should keep in your mind. If we have the series cos alpha plus cos of alpha plus beta plus cos of alpha plus 2 beta plus dot 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 to n terms, then this is equal to sin of n beta by 2 divided by sin of beta by 2 times cos of alpha plus n minus 1 times beta by 2. Okay, so these two trigonometric series, okay, and their summation. Okay, summation. Here this is sine alpha plus sine of alpha plus beta plus sine of alpha plus 2 beta plus dot 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 2 n terms. This is equal to sine of n beta by 2 divided by sine of beta by 2 times sine of alpha plus n minus 1 times beta by 2. Cos of alpha plus beta plus cos of alpha plus 2 beta plus dot 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 2 n terms. This is equal to sine of n beta by 2 divided by sine of beta by 2 times cos of alpha plus n minus 1 times beta by 2. Okay, understand? I hope you will understand. Now, wait for a moment. Okay, please wait for a moment, and we will discuss practice questions 1 this chapter. Okay, so please wait for 1 minute. Okay, students, now we will discuss some practice questions 1 trigonometric functions and equations. See here, question number 1. In this question, we have 2 sin theta divided by 1 plus cos theta plus sin theta. This is equal to x. Okay, then we have to find 1 minus cos theta plus sin theta divided by 1 plus sin theta is equal to what? We have given here 4 options. You have to choose the correct answer from the given options. So everyone, try it by yourself first, okay, and give your answer in chat section. Here, which option is correct? Please write your answer in chat section. Everyone, take your time and try it, and give your answer. Everyone, give your answer. Very simple question. Which option is correct? Okay. Now see which option is correct. Okay. The correct answer is here option A. So first of all, everyone match your answer with the correct answer. Okay. Now see here, formula and key points. Okay. Here we will use cos square equal to 1 minus sin square x. Okay. You will know the identity sin square x plus cos square x equal to 1. From here, from there we get cos square x equal to 1 minus sin square x. Okay. We will use these points. Now let's start the solution here. So given here 2 sin theta divided by 1 plus cos theta plus sin theta is equal to x. Okay, we have given this equation, and now from here you can write x as 2 sin theta times 1 plus sin theta minus cos theta divided by 1 plus sin theta square whole square minus cos square theta. Here we multiply and divided by 1 plus sin theta minus cos theta. Okay, and we obtain in numerator 2 sin theta times 1 plus sin theta minus cos theta. In denominator we obtain 1 plus sin theta whole square minus cos square theta. Clear? And here you can write this as 2 sin theta times 1 plus sin theta minus cos theta. Okay, and you can expand by using a plus b whole square formula, that is a square plus 2ab plus b square. Okay, you get 1 square plus sin square theta plus 2 sin theta. Then you can write you can use this formula cos square x equal to 1 minus sin square x. So you can write cos square theta is equal to 1 minus sin square theta. Okay, now let's simplify this. So therefore you get x equal to 1 plus sin theta minus cos theta divided by 1 plus sin theta. Okay, how we obtain here? You can easily prove it. Okay, so x equal to 1 plus sin theta minus cos theta divided by 1 plus sin theta. So the value of 1 minus cos theta plus sin theta divided by 1 plus sin theta is equal to x. Okay, and this is our final answer. So I hope you will understand. Do you have any doubt? I hope it's clear to all of you. So now moving to the next question. In this question here, if alpha this is equal to 3 pi by 4, then we have to find the value of square root of cosec square alpha plus 2 cot alpha. Okay, and here we have given 4 options. Amongst the given options, we have to find the correct answer. Okay, so everyone try it by yourself first and give your answer in chat section. Take your time, okay, and give your answer. Everyone try it. Try it and give your answer in chat section. Very simple question. Okay, which option is correct? Write your answer. Okay, so now let's check which option is correct here. Okay, the correct answer is C. Okay, not A. Correct answer is C here. Now we will see which key formulas or points we will use here. So here we will use key formula cosec square alpha equal to 1 plus cot square alpha. Okay, so now let's solve this. So here we start with the expression, that is square root of cosec square alpha plus 2 cot alpha. Clear? So now using the identity for cosec square alpha, here now if you substitute, then you will get square root of 1 plus cot square alpha plus 2 cot alpha, and this expression can be written as square root of 1 plus cot alpha whole square. Okay, and you can write this as mod of 1 plus cot alpha. Okay, and now you have to check at point alpha equals 3 pi by 4. So see here. So given that alpha equals 3 pi by 4, so now you can evaluate cot alpha. Okay, so cot of 3 pi by 4, this is equal to minus 1. How we obtain? You can obtain by using cot of pi minus pi by 4. Okay, so cot of pi minus pi by 4, that is cot of minus cot of pi by 4, that is minus 1. Then since 1 plus cot alpha, this is equal to 1 minus 1, this is 0. Okay, and the absolute value simplifies accordingly. So for angles in the second quadrant here where 3 pi by 4 lies, so cot alpha is negative, so mod of 1 plus cot alpha, this is equal to minus of 1 plus cot alpha. Clear? Not plus of 1 plus cot alpha. Here we take minus of 1 plus cot alpha, that is minus 1, minus of 1 plus cot alpha, that is minus 1 minus cot alpha. Okay, not 1 plus cot alpha. Here we take the minus sign. Why? Because here cot alpha is negative. Cot alpha is negative in the second quadrant. Okay, that we have studied in our lecture. Hence the value of the expression is minus 1 minus cot alpha. Understand? Is it clear to all of you? Do you have any doubt? If you have any doubt, then you can ask. Okay, is it clear to all of you? Can we move to the next? Please write in chat section. If it's clear, then write CLR in chat section. Everyone. I hope it's clear to all of you. Now moving to the next. In this question, we have to find the least value of cosec square x plus 25 sec square x. Okay, and here we have given 4 options. So find the correct answer from the given options. Everyone try it yourself first and give your answer in chat section. Everyone try it. Find the least value of cosec square x plus 25 sec square x. Everyone try it. Try it and give your answer in chat section. Give your answer. Very simple question. Okay, now let's see which option is correct here. The correct answer is D. Okay, note this. Correct answer is D. Now see which formula and key points we will use to solve this problem. Here we will use formula cosec square x equal to 1 plus cot square x. Okay, and sec square x equal to 1 plus tan square x. Now let's solve this question. So here we have cosec square x plus 25 sec square x is equal to 1. Okay, and here you can replace cosec square x as 1 plus cot square x. Okay, so this is equal to 1 plus cot square x, and you can replace sec square x as 1 plus tan square x. So you get 1 plus cot square x plus 25 times 1 plus tan square x. Now if you simplify, then you will get this is equal to 26 plus cot square x plus 25 tan square x. Clear? And then here you can write this is as 26 plus 10 plus cot x minus 5 tan x whole square. How we get? Here we subtract and we add and subtract 10. Okay, so 10 plus 10 minus 10, then cot square x plus 25 tan square x. Then we use here if we expand this, and then you can see how we arrange. Okay, so cot x minus 5 tan square whole square, this is equal to cot square x minus 10 tan x cot x plus 25 tan square x. Okay, so this is how we obtain 26 plus 10 plus cot x minus 5 tan x whole square. So this is always positive. Okay, this is greater than or equal to 0. So this is always greater than or equal to 36. Okay, this is always greater than or equal to 36. And here we have to find the least value of cosec square x plus 25 sec square x. So what is the least value of this? So the least value of cosec square x plus 25 sec square x is 36. Understand? And this is our final answer. So I hope you will understand. Okay, and now moving to the next. In this question, we have tan a plus sin a equal to m and tan a minus sin a equal to n. Okay, and we have to find the value of m square minus n square whole square divided by mn. So here we have given 4 options. So you have to choose the correct answer from the given options. So everyone try it and give your answer. So try it by yourself first and give your answer in chat section. Okay, write your answer as which option is correct. Okay, everyone try it and give your answer. Very simple question. Everyone try it. Try it and give your answer. Try it and give your answer. Please try it. Everyone, try it and give your answer. Which option is correct? I hope you are trying. Okay. So here we will check which option is correct. The correct answer is option C. Okay. So everyone match your answer with the correct answer. Now let's start the solution. Since we have tan a plus sin a is equal to m and tan a minus sin a equal to n. Okay. Now if we add m and n, so m plus n, this is equal to 2 times tan a. Okay, and m minus n, this is equal to 2 times sin a. Okay, understand? And if we multiply m and n, so mn, this is your tan a plus sin a times sin a, tan a minus sin a. Okay, that you can use here a plus b times a minus b formula, that is a square minus b square formula. Okay, so this is equal to tan square a minus sin square a. And now you have to find the value of m square minus n square whole square divided by mn. Okay, so m square plus minus n square divided whole square divided by mn, this can be written as m plus n whole square times m minus n whole square divided by mn. Okay, so this is equal to 2 tan a whole square times 2 sin a whole square divided by tan square a minus sin square a. Okay, clear? And this is equal to 16 times tan square a times sin square a divided by sin square a times tan square a. Okay, you can simplify tan square a minus sin square a. This is actually sin square into tan square A. Okay, and here tan square sin square A and sin square tan square will be cancelled to each other, and you will get this is equal to 16. So therefore the value of m square minus n square whole square divided by mn, this is equal to 16. Is it clear to all of you? If it is clear, then write in chat section CLR. Everyone, is it clear to all of you? Everyone, do you understand? It's clear to all of you? Very simple. Okay, just we have done step by step. Okay, and we have found the value of m square minus n square whole square divided by mn. Okay, first we calculate here m plus n and m minus n, then we multiply mn. Okay, and then we simplify and we got the answer 16. Clear? I hope you all understand. Now moving to the next. In this question here we have a cos cube alpha plus 3a cos alpha into sin square alpha equal to m, and a sin cube alpha plus 3a cos square alpha times sin alpha equal to n. Okay, then you have to find m plus n whole to the power 2 by 3 plus m minus n whole to the power 2 by 3 is equal to what? You have given 4 options, so you have to choose the correct answer from the given options. Okay, so first of all, try it by yourself and give your answer in chat section. Everyone, try it. Take your time and try it. Everyone, and give your answer. I hope you are trying. So now check which option is correct here. The correct answer is option C. Okay, so you have to match with your answer. Here the correct answer is C. Here we will use the formula sin square x plus cos square x equal to 1. Now let's solve this question. So given here a cos cube alpha plus 3a cos alpha into sin square alpha equal to m. Okay, and a sin cube alpha plus 3a cos square alpha times sin alpha equal to n. Okay, these are given. Therefore m plus n, this is equal to a cos cube alpha plus 3a cos alpha into sin square alpha plus 3a cos square alpha times sin alpha plus a sin cube alpha. Okay, just we added m and n and we got it this. If you simplify, then you can use here a cube plus 3a square b plus 3ab square plus b cube formula, that is a plus b whole cube formula. Okay, so first common out a and then apply a plus b whole cube formula. So this is equal to a times cos alpha plus sin alpha whole cube. And similarly you can get m minus n, this is equal to a times cos alpha minus sin alpha a whole cube. Therefore now m plus n to the power 2 by 3 plus m minus n to the power 2 by 3, this is simply equal to a to the power 2 by 3 times cos alpha plus sin alpha whole square plus cos alpha minus sin alpha whole square. Okay, so here we first common out a to the power 2 by 3. Okay, here this is full this is multiplied with this one cos alpha plus sin alpha whole square and cos alpha minus sin alpha whole square also. Okay, and this is equal to a to the power 2 by 3 times 2 times cos square alpha plus sin square alpha. Okay, you all know cos square alpha plus sin square alpha is 1. Okay, so you simply this is equal to 2 times a to the power 2 by 3. So our final answer is 2 times a to the power 2 by 3. Simple. Okay, and very easy. Just here first we write what we have given. Okay, and then we find m plus n and we found m minus n, and then we simplify and we got our answer. Okay, understand? So I hope you will understand. So now moving to the next. In this question you have the expression 1 plus cos of pi by 8 times 1 plus cos of 3 pi by 8 times cos of 1 plus cos of 5 pi by 8 times 1 plus cos of 7 pi by 8. Okay, and you have to find the value of the expression, and you have given 4 options, so you have to find which option is correct here. So first of all, try it yourself first. Okay, and give your answer in chat section. Everyone try it. Everyone try it and give your answer. Try it and give your answer. Which option is correct? Which option is correct here? Simple question. Okay, give your answer and write your answer in chat section. Which option is correct here? Everyone try it. I hope you are trying. Okay, so see here now, which option is correct? The correct answer is option C. The formula and key points here, we will use sin square x equal to 1 minus cos square x, this formula. Okay, now let's solve this question. So given expression is 1 plus cos pi by 8 times 1 plus cos of 3 pi by 8 times 1 minus cos of 3 pi by 8. Okay, how? Because here you can see cos of 5 pi by 8, this is equal to cos of you will get you can write cos of 5 pi by 8. Okay, this is equal to cos of pi minus 3 pi by 8. Okay, and cos of pi minus 3 pi by 8, this is simply minus of cos of 3 pi by 8. Okay, so that's why here 1 plus cos of 5 pi by 8 is 1 minus cos of 3 pi by 8. Okay, similarly 1 plus cos of 7 pi by 8, this is 1 minus cos of pi by 8. How? Because you know cos of pi minus pi by 8, this is equal to minus cos pi by 8. Okay, so that's why 1 plus cos of 7 pi by 8 equal to 1 minus cos of pi by 8. Okay, now let's simplify. Here if we multiply 1 plus cos of pi by 8 times 1 minus cos of pi by 8, here you can use a plus b times a minus b formula, that is a square minus b square. Okay, so this is equal to 1 minus cos square pi by 8, and here 1 plus cos of 3 pi by 8 times 1 minus cos of 3 pi by 8 is equal to 1 minus cos square 3 pi by 8. Okay, now use this formula, sin square x equal to 1 minus cos square x. So this is equal to sin square pi by 8 times sin square 3 pi by 8. Okay, this is equal to sin square pi by 8 times cos square pi by 8. And this is equal to 1 by 4, 2 times sin of pi by 8 times cos of pi by 8 whole square. Okay, and you know 2 sin theta cos theta equal to sin 2 theta. This is equal to 1 by 4 sin of 2 pi by 8 whole square. Okay, and this is equal to 1 by 4 sin of pi by 4 whole square. This is equal to 1 by 4 times 1 by root 2 whole square, that is 1 by 2. This is equal to 1 by 8. Okay, and this is our final answer. So I hope you will understand. So if you understand, then write CLR in chat section. Okay, and otherwise if you have any doubt, then you can ask. Okay, do you have any doubt? Do you have any doubt? Everything's clear? If you have no doubt, okay, if all the things are clear, then please write in chat section CLR. Everyone. Do you have any doubt? Do you have any doubt? Please mention in chat section. If you don't have doubt, then no doubt. Okay. Is it clear to all of you? Do you have any doubt? No doubt? I think you will understand. Okay. Now, so I stop here this lecture. Okay. So thank you very much. Thank you for your attention. I hope this lesson was helpful to all of you. And stay tuned for physics class. Hello students, in today's lecture we are going to learn about current electricity and this is theory part. This is our disclaimer. So let's see uh, the topic which we will cover in today's lecture. So first we will see electric current, then we will discuss current density. After that we will learn drift velocity, then we will study Ohm's law, then electrical resistivity. After that, resistance of different materials. Then we will discuss VI characteristics of ohmic and non-ohmic conductors. After that, we will discuss series combinations of resistance. Then parallel combination of resistance. And last, we will see temperature dependence of resistance. So these are the topics of the today's lecture. Okay everyone. So the first topic is electric current. So what is electric current? If we talk about electric current, so we can say the flow of charges. Okay, electric current is defined as the amount of charge flowing across any cross section of wire per unit time. So if charge delta q passes through the area in time interval delta t at uniform rate, then current I is defined as I equal to delta q divided by delta t. Okay, so we can understand from the diagram, if the charge is uh, passing our delta q in delta t time, then we calculate current. So as we know, delta q upon delta t, and the SI unit of electric current is ampere. Okay, so the flow of electric charge through any cross section of wire per unit time is known as electric current. So look at here figure, the charges are flowing here from positive q to negative q in the direction of the electric field. Okay, and the cross section area here, let's consider A. So the charge is flowing across this section of the wire per unit time is known as electric current. Next is if we talk about the conventional direction, so we can say the conventional direction of current flow is the direction of positive charge flow or opposite to the direction of negative charge flow. Actually, we can say the movement of free electrons occurs from negative terminal to uh, we can say from negative terminal to positive terminal of the battery, but conventionally we take the direction of the current as positive to negative. Okay, or we can say opposite to the flow of movement of electrons. So electric current is a scalar quantity. What is the meaning of scalar? It means it has only magnitude, there is a no direction, because when two currents meet at a point, their resultant current will be the algebraic sum of those currents, not vector addition. Okay, so look at the figure, there is a copper conductor. Okay, look at here, This is a copper conductor. And a battery is connected as a voltage source. This is the battery as a voltage source. Now electrons flow from negative to positive terminal. Negative to positive terminal. Okay, look at here, this one. And the conventional flow of current is positive to negative. Okay, so we know electric current is a scalar quantity, so we can add this. Next is current density. As we have just studied the concept of current, in current we observe how many charges are flowing per second through its entire cross section area. Okay, that is current. But when it comes to how much current is passing through a unit area, and current means we are talking from positive to negative, that is current is moving from the positive terminal of battery to the negative terminal. But if we consider per unit area how much current is passing through per unit area, then its value will be different. Okay, J equal to I by A. It means here J represents density and I current per unit area. So it is a it is a vector quantity. It means it has both magnitude and direction. Look at here, J equal to I by A. Okay, unit of current is ampere and unit of area is meter square. So whole unit becomes ampere per meter square. Okay, if we talk about the vector form of current density denoted by capital J, so we can say J equal to sigma into E. This is the vector form of current density, where J is the current density vector, unit is ampere per meter square. Okay, and here uh, E is the electric field applied to this conductor. In a metallic conductor, the movement is of free electrons, not of positive ions. J equal to sigma E. So sigma equal to 1 upon rho, which is equal to n E square tau divided by m. Sigma here is the electrical conductivity of the material and unit is Simon per meter. Okay, and E is the electric field vector, unit is volt per meter. Okay, so this is the current density. Now we will talk about the drift velocity, and this is very important concept for the exam. So let's talk about drift velocity. Drift velocity is the average uniform velocity that conduction electrons acquire in a metallic conductor when an external electric field is applied. Okay, so observe the figure. Look at here in the figure. When there was no electric field, okay, electrons were performing zigzag motion, or we can say random motion. All right, and when the electric field was applied, when the electric field was applied, electrons started flowing in a particular direction. Look at here, started flowing in particular direction towards right direction. Okay, and the velocity of electrons in a particular direction due to the electric field is what we called drift velocity. So the relation for drift velocity is Vd equal to minus E divided by m into tau. Here tau is the tau known as the relaxation time, and this small e is charge on an electron,
and the charge is 1.6 into 10 to the power minus 19 coulomb, and capital is the electric field. Okay, capital is electric field, m is the mass of the electrons, and tau relaxation time. Clear everyone? Any doubt here? If yes, write in the chat box. No doubt? So, what is drift velocity per unit electric field? This term is called mobility of electrons. Okay, drift velocity per unit electric field is called the mobility of electrons. So, we can say mobility is equal to what? Mod of Vd divided by E is equal to E into tau divided by m. Drift velocity per unit electric field. Okay. Now, when electric current flows through a conductor, we can write in the terms of drift velocity. So, the formula can be expressed as I equal to N E A V D. Okay, where A is the cross section area of conductor, N is the number of conduction electrons per unit volume. All right. And Vd is the drift velocity of electrons, and E is the charge of one electron. Next is Ohm's law. You know Ohm's law? Ohm's law applies here. So think about it. So let's see Ohm's law. Ohm's law states that if the physical conditions such as temperature, mechanical strain, etc., are kept constant, okay, then current I flowing through a conductor is directly proportional to the potential difference across it, its two ends. It means we can say V is directly proportional to I when the physical conditions of a given conductor such as temperature, mechanical strain or stress are kept constant. At that time, the current flowing through the conductor will be directly proportional to the potential difference across its two ends, and the physical condition of the conductor should remain the same. Why? Because if the physical condition changes, then the resistance of the conductor will also change and the Ohm's law will not be followed. So I is directly proportional to V, or we can say V is directly proportional to I. So for removing proportionality sign, there is a constant that is R. So we can say V equal to Ri. So we have a relation V by R equal to R, uh, and here R is a constant. Okay. R depends on the nature of the material and given dimension. It means R depends on nature of material. If nature of the material is changes, then the value of R will also change. And if we talk about the SI unit, so we can say SI unit of I is ampere, and SI unit of uh, volt, here V is the potential here. SI unit of potential is joule per coulomb or volt. All right. SI unit of electrical resistance is ohm. Okay, and its dimension is ml square t raised to the power minus 3 a raised to the power minus 2. So these are the very important terms for the exam. Now we will discuss electrical resistivity. Okay. So electrical resistivity. So we can say resistance of any material depends on its geometrical factors such as length, cross sectional area, and the nature of the substance from which the resistor is made. Okay, if we consider a rectangular slab whose length is L and cross sectional area is A. Okay, now what we do is we place one slab like this. Okay, second one, we place one slab like this and then place another slab to next to it. Look at here, this, it means its length has now doubled. Okay, now think, when an electron or charge moves from uh, this side, okay, from this side, so it will have, we can say, it will have to travel a longer path inside the conductor. Yes or no? So due to which it will experience more resistance, and that is, as we increase the length of the conductor, the resistance also increases. Okay, as I just mentioned, resistance is a property. Okay, so we are talking about resistance, so resistance is directly proportional to length. All right, meaning the greater the length, we can say greater the resistance. Okay, so resistance is directly proportional to length. The great resistance is inversely proportional to cross sectional area. Okay, suppose you are entering a room, all right, and when you enter and the room is large, even if some people are sitting, you will easily pass through that room. Yes or no? But if the same room becomes small when you enter, it's obvious that your space to travel has decreased. Yes or no? Due to which you will feel some resistance. So when you pass through, you will feel that there is a less space, which means resistance is inversely proportional to area. Okay, so we can say R is directly proportional to L. L is the length of the slab, and R is inversely proportional to A. Okay, now listen carefully. uh, R is inversely proportional to A, or we can say R is directly proportional to 1 by A. Okay, 1 by A, if we talk about 1 by A, it means a complete term. If we talk about only A, so we can say R is inversely proportional to A, but directly proportional to 1 by A. Okay, so now combining these two relations, relation first and relation second. So from these two relations, we get a third, one more relation, that is R is directly proportional to L by A. Okay, now there is a proportionality sign. All right, so to removing proportionality sign, we will use a constant, that is rho here. So we can say R equal to rho L divided by A. All right, so to remove this proportionality sign, rho will come, so the relation become R equal to rho L divided by A, and let this is equation 4th. Here the rho is a constant of proportionality called resistivity. All right, and rho is, we know, m divided by n e square tau. Okay, m means mass of electron, n means number of electrons per unit volume, and e is the electronic charge, and tau is the relaxation time. Now we will discuss resistance of different materials. So we know three types of materials: conductors, insulators, and semiconductors. Yes or no? So first we will talk about conductors. Okay. So if we talk about the definition, so we can say conductors are materials in which electric current flows very easily. Okay. Thus materials that radially allowed electric current to flow through them are called conductors. And if we talk about their resistance, so they exhibit minimum resistance. Okay. Examples: copper, aluminium, silver. So these are the examples of conductors. Second material is insulators. Okay. So if we talk about the insulators, so we can say insulators are materials that do not allow electric current to flow through them. Alright. They possess minimum resistance. If we talk about example, so we can say rubber, glass, plastic. So these are the examples of uh, insulators. Okay. Now third type of material is semiconductors. Okay. And we will also discuss about semiconductors in detail in upcoming chapters. So if we talk about the semiconductor, so we can say uh, materials with electrical conductivity between that of conductors and insulators. So their conductivity lies between that of conductors and insulators. It is neither as high as conductors nor as low as insulators. And their resistance intermediate. All right. If we talk about examples, so we can say silicon, germanium. These are the examples of a semiconductor. And more about the semiconductors we will learn in 14th chapter. So conductors have low resistance and high conductivity, whereas insulators have high resistance and low conductivity. And if we talk about the semiconductors, so we can say the resistivity or conductivity of semiconductors can be easily altered. This is why semiconductors have such as extensive applications. All right. Next is resistance of different materials. So if we talk about a perfect conductor, then the resistivity should be 0. So if we talk about a perfect conductor, then its resistivity should be 0, because a perfect conductor does not oppose charges, and a perfect insulator should be such that it never allows charges to flow, meaning its resistivity should be infinite. But these are ideal limits, whereas actual resistivity lies between these two. For instance, if we talk about the resistivity of conductors, silver, copper, aluminium, tungsten, okay, nickel, iron, chromium, mercury, okay. So the resistivity of all these is different. All right. So metals have low resistivity of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. Okay. So this is the range. While insulator like glass or rubber have resistivity some 10 to the power 18 times or even more greater. Okay. And generally, good electrical conductors like metals are also good conductors of heat, while insulators like ceramic and plastic materials are also poor thermal conductors. So look at here in this table. So there is a materials, conductors, alloys and insulators, and their examples and their resistivity measured in ohm meter. Okay. So uh, here we can compare the silver have, look at here, the resistivity is very low, okay, and their conductivity is very high, okay. Similarly for alloys and insulators. All right. VI characteristics of ohmic and non-ohmic conductors. You know, two types of conductors, ohmic conductors and non-ohmic conductors. So substances obeying Ohm's law are known as ohmic conductors, okay. For example, metals and their alloys. And if we talk about what is the ohmic and non-ohmic conductor, so we can say ohmic refers to substances that obey Ohm's law, and non-ohmic refers to those that do not obey Ohm's law. Okay. So Ohm's law is applicable only when V is proportional to I. This is applicable only when the physical conditions of the object remains constant. Okay. If we plot the characteristics of our devices, that is a voltage versus current, okay, look at here, voltage versus current. So then if we obtain a straight line, okay, in second we obtained a second straight line, we say that uh, it is obeying Ohm's law, but from uh, origin to this point, okay. And then a non-linear region forms. All right. This represents non-ohmic behavior. When we plot a current versus voltage graph, and instead of a straight line, a curved line appears. Look at here, a curved line appears. Then it is called non-linear plot. For example, electrolytes, gases, thermoionic tubes, resistors, rectifiers, all these are non-ohmic substances. They do not obey Ohm's law. Okay. Whereas metals or alloys obey Ohm's law, and their graph is a straight line, but their physical conditions should remain constant. All right, everyone, if you have any doubt, please ask. Any doubt? Yes or no? Karthik, VK, Varsha? If yes, please ask. All right, very good. Now, let's see series combinations of resistors. This is very important concept for exam. So I personally recommend you. Please listen carefully. So we have a two combinations. First, series combination of resistors. Second, parallel combination of resistors. So assume here you have a two resistors, or suppose three resistors, R1, R1, R2 and R3. Okay, we have a three resistors, R1, R2 and R3. Okay, and if we talk about series combination, so we can say AND to AND connection. Okay, so look at here. So this is the first resistor, and their AND is connected with uh, start and is connected with AND of second resistor, or we can say uh, start this one, and of second resistance this one, and this is AND of third resistance, AND to AND connection, or we can say chain rule. Okay, or like a chain. So they are connected in series R1, R2, R3. Okay, so there is a only one path. If suppose if the current I flows from the source, so there is a only one path. So we can say in series combination the current will never be changed. Okay, current flows with the same value everywhere. When we add the resistance values of individual resistors, the equivalent resistance of the circuit will be obtained. The equivalent resistance in the series are equal to R1 plus R2 plus R3. Look at the image here. Look at here. There are three resistors. Voltage is applied and I current is flowing. And these three resistors are in series, AND to AND connection. Okay. Their equivalent resistance will be obtained simply by adding the resistance values. So the total resistance of the circuit is found by simply adding up the resistance value of the individual resistors. So suppose the if we talk about the first resistor, okay, so their resistance should be R1. For second resistor, resistance should be R2, and for third R3. So this is the series combination. In series combination, current should be same through each resistor. Okay, so we can directly add their resistance value, equivalent resistance, that is R equal to R1 plus R2 plus R3. Okay, clear? Now second combination is parallel combination of resistance. In case of a parallel combination of resistance, uh, look at here figure. One terminal one terminal of the first resistor and one terminal of the second resistor and the one terminal of the third resistor are all connected at a single point, and that single point is this one. Yes or no? And the other terminals of R1, R2 or R3 are also connected together. All right, in the look at here in this one. So this is the parallel combination. Okay, you can observe that both terminals are connected to common points, whereas in a series connection only one terminal is connected to the next component. Therefore, a parallel circuit is a circuit in which resistors are arranged such that one set of their terminals is connected together and their other set of terminals is also connected together. So the current entering this parallel combination, for instance, current I, and that current I divides into three different paths: I1, I2, and I3. Okay, so the voltage across them remains the same because the potential difference will remain constant. So the voltage across each resistor will be same, okay, in parallel combination. Now to find the total resistance for a set of resistors, it will be calculated when we take the reciprocal values of the individual resistances. Okay, add them and then equate them to the reciprocal of the total resistance. So look at here. If we talk about the equivalent resistance, so we can take the reciprocal. 1 upon R is the reciprocal. Okay, R is the reciprocal. So equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So if you want to find out the reciprocal, so add them and then uh, find out the value of R. So that value of R should be reciprocal value, equivalent value. Okay. Now we will see temperature dependence of resistance. All right. So here, when now let's look at here. Now let's look at the temperature dependence of resistance. What effect increasing or decreasing temperature has? So when the temperature increases, in the case of metals, their resistance increases or its resistivity increases. Yes or no? So if we increase the temperature in case of metals, their resistance increases. And in the case of semiconductors, resistance decreases with increasing temperature. Now to understand resistivity, you just saw that rho is equal to m upon Ne square tau. So here uh, three graphs, resistivity versus temperature, then again rho versus temperature for uh, different material. Okay, on y axis temperature, and on on x axis temperature, on y axis resistivity. So find out the difference between these three. Think about it. Yes, everyone, think about it and tell me the difference. Anyone? So look at here in first one graph. This is the resistivity rho t of copper as a function of temperature T. Okay, first one. Second one is the resistivity rho t of nichrome uh, as a function of absolute temperature T. And third one, temperature, uh, we can say temperature dependence of resistivity of a type of semiconductor. So third one for semiconductor. Okay. So this graph shows their graphical variation. Yes or no? Okay. And the relation is written as to formula to calculate resistance. So it has been understood why resistivity increases and with increasing temperature. So in case of metals, and why it decreases in semiconductor. So the relation is R of theta equal to R naught into 1 plus alpha theta. Here theta represents the change in temperature, and rho theta equal to rho naught 1 plus alpha theta, where R naught and rho naught are the values of resistance and resistivity at 0 degree Celsius, and R theta and rho theta at 0 degree Celsius. Alpha is the temperature coefficient of resistance. Okay, any doubt? Yes or no? Yes or no? Anyone? All right. So now let's summarize today's lecture in few points. First, electric current. Electric current is a flow of electric charge typically measured in amperes. It can be classified as a direct current DC or alternating current AC. Okay, and current density, the formula is J equal to I by A. Then drift velocity. Drift velocity is the average velocity of charged particles such as electrons in a conductor due to an applied electric field. Okay, and it is generally small but leads to a net current flow. Then Ohm's law, V is equal to IR. Then electrical resistivity, we know the formula, that is uh, represented by rho, rho equal to R into A divided by L. Yes or no? Then resistance of different materials. Each material has different resistance because the movement of electrons within them varies. Then VI characteristics of ohmic and non-ohmic conductors. Ohmic which follow the Ohm's law, non-ohmic which do not follow the Ohm's law. Then series combination of resistors. The formula is for equivalent resistors is what? R equal to R1 plus R2 plus R3. That we can directly add. And for parallel combination of resistance, 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And temperature dependence of the resistance. So the resistance of most materials changes with temperature. Typically, it increases for conductors and decreases for semiconductors as temperature rises, affecting current flow. All right. Now, thank you for your attention. Now we will solve some practice questions based on these concepts. So, are you ready for the practice question? Everyone, please answer. Yes or no? Write in the chat box. Okay. Now students, we will solve some practice questions based on current electricity. These questions helps you to understand the concept and build your problem solving skill. Okay. This is our disclaimer. So here we will solve some practice questions based on current electricity. So our first question, a wire of length L and three identical cells of negligible internal resistance are connected in series. Due to the current, the temperature of the wire is raised by delta T in a time small t. A number of n of similar cells is now connected in series with a wire of the same material and cross section but of length 2L. The temperature of the wire is raised by the same amount delta T in the same time T. The value of n is what? Okay. So in this question, you have to find out the value of n. Question asks us what the new number of cells n will be if the same change in temperature delta T occurs in the same time T in second situation as well. We need to find the value of n. So given options, option A 4, option B 6, option C 8 and option D 9. So which one is correct? Please solve this question everyone. You have some time. After that we will provide the solution of this question. Okay everyone? Please solve and tell me the answer. Everyone. Yes, which one is correct? Okay, please solve. You have to find out the value of n. Okay. Yes, which one is correct? A, B, C, anyone? Okay. B. Okay. Let's see the correct option. So B option will be correct. So according to question, uh, three identical cells of negligible internal resistance are connected in series. Okay. So look at here in the figure. There is a three identical cells are connected in series. End-to-end connection known as series connection. All right. So the first case is that there are three identical cells whose internal resistance is negligible, and these are the connected to a wire of length L. Look at here. Look at this one. Okay. Now if we assume that the resistance of this wire is capital R, okay, then capital R can be written as rho into L divided by A. This is the formula to calculate the resistance. Yes or no? So now we can name it this way. If we are in the second case, meaning uh, length doubles, okay, so we can say R1 here for the first case, R1 equal to rho into length is 12 divided by A. So when we solving this, you will be get uh, R1 equal to 2R, and we know the density, that is mass upon volume. So mass is m and volume should be Al. Okay, so D equal to m upon Al. Now m become Al into D. Okay, volume into density, and for the first case m1 should be A into 2 into L into D is equal to 2m. In the second case, the mass will be A into 2 into LD, which is the twice the previous mass. So in the second case, mass will be 2m. Now the heat produced in the first case, that is H1 equal to 3E whole square divided by R into T. Okay, so we can equate equal to this ms into delta T, and let this equation first. In second case, uh, we are given n cells, and the resistance in the second case is 2R because the length is double in the second case. So the heat produced in the second case will be H is equal to Ne whole square divided by 2R into T. So it is equal to 2 into ms delta T, and let this is equation second. So on solving equation first and second, we get n equal to 6. So after solving equation first and second, you will be get 6. Okay everyone, any doubt? Okay, good. Now second question. In a large building, there are 15 bulbs of 40 watt, 5 bulbs of 100 watt, and 5 fans of 80 watt, and 1 heater of 1 kilowatt. The voltage of the electric mains is 220 volt. The minimum capacity of the main fuse is what? Okay, so here you have to find out the minimum capacity of the main fuse. Given options: option A 8 ampere, option B 10 ampere, option C 12 ampere, and option D 14 ampere. Okay, and this question is asked in JEE 2014. Okay, you have to find out the uh, minimum capacity of the main fuse. Minimum fuse capacity means the maximum current that can safely flow in the circuit without blowing the fuse. Okay, so to solve this problem, first need to calculate the total power consumption in the building. Okay, after this, using the electrical power formula, you know the electrical power formula, V equal P equal to V into I. So we will calculate the total current I, where P is the total power and V is the voltage. The value of current obtained will be minimum fuse capacity. Okay everyone, please solve this question. You have some time. Yeah, I'm expecting answer from everyone. So please solve. Which one is correct? C option? Anyone? Okay. B option. All right. C. Okay. Okay. Please solve. A. I think all options are correct. Please solve. Okay. So the correct option is C. Okay. Let's see the solution. So firstly, we will calculate the total power consumption. Okay. So the total power consumption will be 15 into 40 plus 5 into 100 plus 5 into 80 plus 1 into 1000. So 15 into 40 equal to 600 and 5 into 100 500. Yes or no? 5 5 into 100 500 and 5 into 80 400 and 1 heater, that is 1 kilowatt, it means 1 into 1000. So when we add all, you will be get the total power consumed. So it should be 2500 watt. Okay. So because here we are getting 600 watts, 500 watts and 400 watts, and this is 1000. So when we add them, the total power consumption is this one, 255 to 2500 watt. As we know that the formula of power, that is P equal to VI. So just to calculate the I, just put the value of P, that is 2500 watt divided by V. So V is, that is given here, 220 volt. Okay. So when we solve this, you will be get 125 divided by 11, which is equal to 11.3 ampere. Okay. Now we need to see what the fuse rating should be. This means what is the current requirement at a given time. So according to the power rating, the current rating calculated for the fuse is 11.3 ampere. So a current of 11.3 ampere will be required. If we install a 11 ampere rated fuse on the mains, it will not work. So because as soon as the current reaches 11.2 ampere, the fuse wire will melt, and meaning the fuse will blow. This means the fuse rating should be more than 11.3 ampere. But no, so much that if the current increases, our equipment or appliances get damaged. So what we will do is, we will take a number slightly greater than 11.3. So the minimum capacity should be 12 ampere. Okay. Clear everyone? Yes or no? Okay. Next question. Are you ready for the next question? So next is, two electric bulbs marked 25 watt to 220 volt and 100 watt to 20 volt are connected in a series to a 440 volt supply. Which of the bulbs will fuse? Now we have connected both these bulbs in series to a 440 bulb supply. So we need to find out which of these bulbs will fuse. So for this, we will have to find the value of current. Okay, it means how much current these bulbs can withstand and how much current will actually flow. Then we will calculate the power rating, which bulb will receive more power due to which it will melt or fuse. So given options: option A both, option B 100 watt, option C 25 watt, and option D neither. Okay, so which one is correct? Please solve this question, everyone. I'm expecting answer from everyone. Please solve, you have some time. Yes, and try to find out the correct option. Okay, all right. So the correct answer is C. All right, let's see the solution. Look at the figure. The question is simplified as shown in this figure. There are two bulbs with rating written on them: 25 watt to 20 volt and 100 watt to 20 volt. Okay, so we have connected both of them to a 440 volt source voltage. Now if we talk about the resistance of this bulb, what will it be? Because we know P equal to V square by R, so from here R will come out as R equal to V square by P. So for 25 watt bulb, R25 equal to 220 volt whole square divided by 25. So when we solving this question, you will be get 1936 ohm. Okay. Similarly for 100 watt, R100 equal to 484 ohm. So bulbs are connected in series. So the total resistance is the sum of individual resistances. Okay, as we studied in the series combination. So what will be R total? We can directly add 1936 ohm plus 484 ohm. So it will be 2420 ohm. Okay. So here in a series, both bulbs carry the same current. Since the 25 watt bulb has higher resistance than the 100 watt bulb, it dissipates more heat and is more likely to fuse. Okay. Clear, everyone? Next question. Uh, Correct setup to verify Ohm's law is what? Among these, you need to find the correct connection: voltmeter connection, ammeter connection, battery connection, and state connection. Okay, so please find out the correct one. So the correct option is A. Okay, let's see the solution. So Ohm's law states that the current I flowing through a conductor is directly proportional to the potential difference across its ends. Yes or no? So when its physical conditions such as temperature, mechanical strain, stretch are kept constant, so we can say V is directly proportional to I. So V equal to Ri, where R is a constant. So now if we want to experimentally study Ohm's law, then the voltmeter should be connected across the resistor parallel, while the ammeter should be connected in series with the resistor, which were getting in the first option. Okay, so according to this, our answer will be A. Yes or no? All right. Next question. This is very important question and little bit tricky. So the question is, six equal resistors are connected between points P, Q and R as shown in the figure. The net resistance will be maximum between uh, PQ, between PR and between QR, or any two points. So which one is correct? Please find out the correct option. Okay, please solve. Here we need to find the resistance between P and R. The equivalent resistance between Q and R will be the connected in series with QP. If we look at it another way, for example, if we find the resistance across QR, then this one will be parallel to them. And so in this way, their parallel and series combination is changing. And due to which we have to tell here across which 2 points are resistance of this circuit will be maximum. Okay, so you have to find out the correct one. Please solve. Which one is correct? Anyone? And this question is asked in JEE in 2013. So the correct option B. All right. Let's see the solution. So across Q and R, two resistances are in parallel. So net resistance will be R by 2. So RQR equivalent is equal to 1 by R plus 1 by R. So it will be R by 2. And across points P and R, three resistance are in parallel. So equivalent should be R by 3. Okay. So resistances across Q and across P and R by 3 and R by 2 are in series. So their resistance will be 5R by 6. The resistance across this will be 5R by 6. Now the resistance, meaning the single resistance that we have taken, is parallel with R across P and Q. So by solving this, we get net resistance as RPQ equal to 5 by 11R and RQR is 4 by 11R and RPR is equal to 3 by 11R. Okay. So when we compare all these three, so you will be get RPQ is greater than RQR greater than RPR. Therefore, RPQ is maximum. All right. Next one. An infinite ladder network of resistance is constructed with 1 ohm and 2 ohm resistance as shown in the figure. Then 6 volt battery between A and B has negligible internal resistance. Then the effective resistance between A and B is what? You have to find out the effective resistance. Okay, so please solve this question. And the given options: option A 3 ohm, option B 2 ohm, option C 6 by 5 ohm, and option D 5 by 6 ohm. There is a 4 options. Okay, so if you have an infinite ladder network where resistances are connected in a such a way that here is 1 ohm and 2 ohm, then 1 ohm, then 2 ohm, and so on, then if one cut from one piece from it, it will still remain infinite. Okay, and if here one add one more piece, it will still remain infinite. Yes or no? So if resistance across one is R, then the resistance across the next section will also be R, and then further on it. So will also be R. Okay, so if we remove one or add one section, the resistance will remains R. It will not make the any difference. We will must use the fact. Okay, so please solve this one. Anyone? So the correct option is B. All right. Let R be the resistance of infinite ladder. Now, since the ladder is infinite, the addition or subtraction of one step will not affect the total resistance of the network. So, its equivalent circuit as is shown in the figure. Look at here, this one. All right. Here, equivalent circuit that will be formed. So, if something is add or subtracted in infinite, it will not make a difference. So, this will be equivalent. So this will become such that the 6 volt battery is with 1 ohm. Here is 2 ohm. Okay, 1 ohm and 2 ohm, and here is a resistance R. So what we will do is we will assume that the resistance here is R, and R is in parallel with 2 ohm, and then these two will be connected in series with 1 ohm. Okay, so if you ignore the 6 volt battery, then the resistance across this series will be 1 ohm. Resistance will remain R. So this concept is being used here. Okay, so now for R, first we will solve this in parallel. So it will be 2 into R divided by R plus 2. Okay, then will we add that this resistance in series with 1 ohm. So it will become uh, we can say 1 plus uh, 2 into R divided by R plus 2. So it is equal to R. On solving this, you will be get R plus R plus 2 plus 2R equal to R square plus 2R, uh, or we can say on simplifying this expression, you will be get R square minus R minus 2 equal to 0. So on solving we get R equal to 2 ohm. Okay, this is just mathematical algebra from this step. All right, next question. In the circuit in the figure below, the potential difference across P and Q will be nearest to what? We need to find out how much voltage drop is occurring across this circuit. After that, if we split it into two parts, one is 20 ohms and other is 80 ohms, then we can find the voltage drop across 20 ohms. This means first we need to find the current in the circuit. Only then we will know the voltage drop, because a voltage drop is always I into R. So to find the voltage drop across a resistance, we will multiply the value of that resistance by current. Then we will get the voltage drop across it. Okay. So which option is correct? Option is 9.6 volt. Option B 6.6 volt. Option C 4 volt, and option D 3.2 volt. Please find out the correct one, everyone. You have some time. Yes, which one is correct? Anyone? So the correct option is D. Okay. So look at here. What is the our circuit? First we will calculate the resistance in it. Okay. So we will simplify this resistance. So 100 ohm is the first. Okay. Then this 80 plus 20 means and then the internal resistance of this battery is also 100 ohm. So the total resistance in the circuit becomes 300 ohm. So the current will be I equal to 48 divided by 300. When we solving this, you will be get 0.16 ampere. So now we need to tell the voltage across PQ. It means what is the voltage drop across it. Okay, PQ. So how much current is passing through the resistance? So when we do I into R, look, this 20 ohm. Okay, 20 ohm. So we will do 20 into 0.16, means 3.2 volts. So the voltage drop across 20 ohm is 3.2 volts. Okay, so the option is correct. Next question. The charge on the 4 microfarad capacitor in steady state is what? So here, what will be the charge on the 4 microfarad capacitor in the steady state? This is the key point here. What does steady state mean? It means a condition where no current is passing through the capacitor. So at that time, we need to tell how much charge will be present in this capacitor, which is 4 microfarad. Okay, and if we want, uh, we can also find it by using the voltage across here, because the formula is Q equal to CV. So how much charge will on it? We can calculate this. So given options, option A 20 by 3 microcoulomb, option B 10 by 3 microcoulomb, and option C 5 by 6 microcoulomb, and option D 10 microcoulomb. So which one is correct? Please solve this question, everyone. You have some time. Which one is correct? Please solve and find out the correct option. Yes. A. Okay. Anyone? The correct option is A. All right. So in steady state, uh, the capacitor becomes fully charged and acts like an open circuit. All right. So the equivalent circuit in steady state is shown in the figure. Okay. So look at here. Uh, there is a 5 ohm resistance, 5 ohm resistance. So the current will be in steady state 10 divided by 5 plus 5 is equal to 1 ampere. Both are connected in series. Okay, so we can add directly end to end connection, 5 plus 5 10. So the potential drop across AB will be 5 volt. So sum of the potential difference across 2 microfarad and 4 microfarad capacitors is 5 volt. As capacitors in series, the charges on them would be same. Let us say it is Q. So from KVL, uh, if we assume this V1 and the other as V2, then the charge is same in both. Okay, so Q by 2 plus Q by 4 equal to 5. Now we will put the value and solve it. You will be get Q equal to 20 by 3 microcoulomb. Okay, everyone. Next question. The temperature dependence of resistances of copper and undoped silicon in the temperature ranges 300 to 400 Kelvin is best described by what? And this question is asked in JEE in 2016. Okay, so here the four options is given. Okay, so you have to find out the correct one. We need to tell who is the increasing and who is the decreasing. Please solve this question. You have some time, everyone. Yes, which one is correct? A, B, C, or D? Let's see the solution. So correct option is C. Okay. So we know that as we studied, uh, as temperature increases, the resistivity of metals also increases and the resistivity of semiconductors decreases. Okay. Now if we look here, we need to tell that from 300 Kelvin to 400 Kelvin. Okay. In this graph, this is for metals. This is a metal that this is alloys, and this is for semiconductor. Okay, so for metal, the range was given between 300 Kelvin and 400 Kelvin, and we look between 300 Kelvin and 400 Kelvin. Our graph is something like uh, look this like this. Okay, here. So it is a straight line. All right. So in this range, our concept behaves like a conductor. So as temperature increases, its resistance will also increase. Whereas in semiconductors, as temperature increases, their resistance decreases because resistivity decreases. And this is the resistivity versus temperature graph. So if resistivity is decreasing, then resistance will also decrease. So in this way, all other parameters have been fixed. Okay. So C answer is correct. All right. Thank you for your attention. That's all for the today. Thank you.